In this beginner's Elasticsearch course, you'll discover how to harness the power of one of the world's most popular distributed search and analytics engine. In this course, you'll learn how Elasticsearch enables lightning-fast search capabilities across massive datasets while providing real-time analytics and visualization possibilities that can transform how your applications handle data. Imad Sadiq developed this course.
Hi everyone, my name is Imad Sadiq. I am an AI and data science engineer at AGC Europe. I am extremely happy to share my first course on the freeCodeCamp YouTube channel. Since I couldn't find an extensive course for beginners that talks about Elasticsearch, I created my own one to fill this gap. This course is for beginners, so even if you know nothing about Elasticsearch, by the end of this course, you will learn a lot of things, and hopefully you will be good at using Elasticsearch. This course is divided into two parts. The first part, you will learn a lot of things about Elasticsearch. I'll talk about indices. I will show you how to index documents, what are the data types, how to use analyzers to analyze text, how to work with embedding models, how to use semantic search, how to use pipelines to transform your data, and other things. In this second part, we are going to use all the knowledge that we have learned to work on a final project. And as you can see in the background, I have a dark background with some stars moving from the bottom of the page to the top of the page. This is the theme that we are going to stick with. It's going to be about astronomy. And in this second part, we are going to use the astronomy picture of the day dataset. I will show you how to use pipelines to transform this data because it contains HTML tags. And then we will try to index the data. After that, you will learn how to use pagination in that website that we are going to build. Also, we are going to provide the user the ability to switch between regular and semantic search. And we will allow the user to use filters to filter documents by date. In this second part, we are going to use Vue.js and FastAPI to develop the full stack web application. In the backend, we are going to use Python. But if you want to use other programming languages, this is possible because Elasticsearch basically is just a server that runs either locally on your machine or in the cloud. And to communicate with Elasticsearch, you make HTTP requests. This course, as you can see from this introduction, contains a lot of stuff. I hope that it is going to be useful and informative. And please, when you finish this course, give me some feedback so that I can make better courses in the future. That's it for the introduction. Now let's get started. Welcome everyone. I am excited to start this series where we will explore the power of Elasticsearch and learn how to build amazing things with it. In this introductory video, I will give you a global view of what we will cover throughout the series. Let's dive in. Elasticsearch is a versatile search engine that offers flexibility in deployment. You can install it locally for personal use or use it in the cloud for large-scale applications. For personal projects, running Elasticsearch locally with Docker is a great option. However, if you are working with an organization handling vast amounts of data, cloud deployment might be the way to go for easier scalability and management. Now let's talk about getting your data into Elasticsearch. Data is organized into indices or vector stores. So in this example, I have 3 indices. These can be stored either locally or in the cloud. Elasticsearch is incredibly versatile, accepting various data types such as pure text, numbers, dates, and even vectors if you want to use embeddings. This flexibility makes Elasticsearch a powerful tool for a wide range of applications. Okay, so once your data is indexed, the possibilities are endless. You can build, for example, powerful search engines, intelligent recommendation systems, and RAG systems, retrieval augmented generation. Throughout this series, we will work on practical examples to apply the techniques you will learn, giving you hands-on experience with great applications of Elasticsearch. While Elasticsearch supports multiple programming languages, we will focus on using the Python client in this series. I hope this overview has piqued your interest in Elasticsearch and its capabilities. In the upcoming videos, we will delve deeper into each topic, providing you with the knowledge and skills to harness the full power of Elasticsearch. Stay tuned and let's embark on this exciting journey together. Hello everyone. In this video, I will show you how to run Elasticsearch locally and how to install all the libraries that you will need in order to interact with Elasticsearch. Visit this website. The link can be found in the description. Here, as you can see in this page, we have two options to run Elasticsearch. You can do that in the cloud or use Docker to install it locally. In this series, I will focus on using Elasticsearch locally. So click on this link and make sure to copy this command. Now open the terminal, make sure that you have Docker installed, and here paste in the following command. So as you can see here, it did not find the image, so it will install it. So I'll wait for this to finish and I will come back. Awesome, so the installation has finished. So now if you want to see the running containers, you can run this command. And as you can see, here it is running. Now, here they say that to verify that the installation was done successfully or correctly, you need to click on this link. So let me do that. And as you can see here, you have some information. Let me zoom in so that you can see better. So here you can see that this is the version that we have installed. So it is running on Docker. And yeah, so if you see this, you now for search, this means that everything is good. Awesome. So now, because as I said in the beginning of this series, we will be using Python to interact with Elasticsearch. So the first thing I always like to do is to create a new virtual environment. So here, because I have Anaconda installed on my PC, so I'll use it. To do that, to create a new environment, you can run the following command, conda create -n, and here you specify the name of the environment. And here I will be using Python 3.11. Click on yes to install all the necessary libraries. And I just want to say, if you do not have Anaconda installed, you can create a virtual environment with using the venv module from Python. Okay, so here the only thing we need to install is Elasticsearch. So pip install Elasticsearch. But here, don't forget, you need to first activate the virtual environment. So let's do that quickly. Conda activate Elasticsearch. And now pip install Elasticsearch. Awesome. So you can see that this package did not take a lot of time to install. And yeah, if you have arrived at this point, you installed everything you need. So see you in the next video. Welcome back. In this video, I will talk about creating an index in Elasticsearch with the Python client. I will start by explaining what an index is, how to create it, and what are the settings you can configure while creating it. An index is a collection of documents that share similar characteristics. Let's illustrate this with an example. Say that you have a lot of products, and for each one, you have a PDF document. In this PDF document, you can have, for example, the name of that product, its price, and the description, etc. Each document will be converted into a JSON object and stored in, for example, the product's index. An index in Elasticsearch is comparable to a database in a relational database system, but it is optimized for storing and searching large volumes of textual, numeric, and structured data. In this image, I show you how to create the index. First, you need to connect to the cluster and then use this create method to create your index. This is very simple to do. Now let's go to the code and show you how to do this. Okay, so here is a notebook that I have created for you. You can go to the description. You will find this on GitHub. There I'll try to put all the notebooks that I will be showing you in these videos. So make sure to check that and download the notebooks if you need. First, you need to connect to Elasticsearch. If you try to run this, it might not work. Why? Because remember, in the previous video, which is the second video in this series, I showed you that you need to install Elasticsearch locally, and we use Docker to do that. So you need to first run the image. So sudo docker start, and here the container is called Elasticsearch. So now it is running, and now if I rerun this cell, let's give it some time because it takes some time to start the cluster. So now you can see that we are connected to Elasticsearch, and here we see the same information as if we click on this link. So you can see that we have the same info that is showed in this website window. Okay, so here it says that we are running on Docker, and the version of Elasticsearch that we are using is 8.15, which is the latest one. Great. So now let's see how to create an index. So because I was testing, the index might be in Elasticsearch, so I will just delete it and then create the index. So if I run this, so here in this output, you can see that it shows us that everything went well and we were able to create the index. Now let's go back to the slides. When we want to create an index, we have some settings that we can tweak. For example, here I will be talking about just the number of charts and the number of replicas. What are they and what do they do? Well, let's say that you have your product index. If you specify that the number of charts should be equal to 2, then Elasticsearch will try to split each document into 2 parts. So here, after the sharding process, you can see that the product index contains 6 parts instead of just 3 full documents. But don't worry, when you make a query to retrieve the data, Elasticsearch knows how to reconstruct the documents to find the information you need. To change the number of shards in the index, it's simple. Just add this key to the settings dictionary, and here I specified 3, so this means that we will split the documents into 3 shards. Now let's move to the number of replicas. A replica is a copy of the data. Let's take our sharded index. Because here I specified the number of replicas as 1, this means that we will duplicate this fragmented index just once. Why we do this? Well, it's simple. When you duplicate the data, you improve system resilience. Let's say, for example, that the first index shuts down. What will happen? If you did not duplicate the data, then the whole system will fall down. So in this case, you can quickly switch to the duplicated index and use it. Also, replicas enable parallel search and retrieval operations, so it makes searching very quick. Again, to change the number of replicas, it's so simple. You just add this key, and here I specify 2, which means that I will duplicate the data twice. Let's go back to the code and let's continue. So here I have this section, and here you can read about what are shards and what are replicas if you want. But here you see that I can specify the number of shards to be 3 and the number of replicas to be 2. So again, I will delete the previously created index and create this new one. And again, I get this response, which means that everything was created successfully. I hope that you now know how to create indices and hopefully understand what happens under the hood. I hope that you found this video helpful. If you did, then please leave a like, subscribe to the channel, and wait for the upcoming videos. See you next time. Welcome back. In this video, I will talk about how to insert documents into an index in Elasticsearch. I will start by explaining the format of the document that Elasticsearch expects. After that, I will show you how to insert one document or multiple documents. Finally, I will talk briefly about mapping. In the previous video, I showed you how to create an index, but how do you add documents to it? Say that you have a PDF file, which consists of just text, or let's say that we have a pure text or even a website. If you want to put that type of document into Elasticsearch, you cannot do that just like that. So you need to convert your document into a JSON format because this is the format that Elasticsearch expects. For example, if you have a PDF file about a product, you could extract the name, the price, the description, etc. This process is necessary and should be done before indexing the documents. Let's say in this example that you have 100 documents, and let's say that we converted them into JSON format and inserted them into this index that I am calling my index. A quick reminder, all those 100 documents must have the same fields. And this is how we do that in the code. You can see it is very simple. You just call the index method and you are done. When inserting the data, there is something that happens under the hood, which we call mapping. Basically, Elasticsearch tries to figure out the data type for each one of the fields you have in your documents. This process, as I told you, is called mapping and is done automatically by default. But if you want, you can force the mapping manually. For example, here, the field created on should be considered as date, and the text and title fields are considered to be text. In a later video in the series, I will talk about the different data types that Elasticsearch supports. So don't worry about this for now. Now back to the code. Again, as always, make sure that Elasticsearch is running locally before running the first step. And then if you see this message or this information printed to the console, this means that the connection is established to Elasticsearch and you are ready to go. Here, as we saw in the previous video, this is how we create an index. So here I delete it if it exists, and after that I just create it. And here I have created a dummy document that contains 3 fields: the title, the text, and the create on field. And we insert it by using the index method. So here you specify that the index should be, so here make sure that the index is the same as the one you have here. So here I made a mistake. Instead of my documents, it should be my index. And here you pass in your document. So I will just run this. And as you can see here, this method returns a response object, which contains some information like the ID, the number of charts, etc. So for example, we can look at this result key, and here it says created, which means that we were able to insert the document into the index. Here we have the number of charts. You can see that the total number of charts is equal to 2. Remember in the previous video, charting means breaking the document into multiple smaller parts. For example, here, this document was broken into 2 parts. Here, if you want, for example, to retrieve your document by ID, you can do that. So this document was assigned this ID. And here, just to verify, you can see that we inserted that document into this index that I called my index. Now to index multiple documents, I have created again a dummy JSON file that contains 3 documents and they have the same fields as before. This is simple. You use the JSON package to read that file and it gives you back a list of documents. Here I created 2 methods. One that inserts a document to the index, and the other one prints the results of that operation. So as you can see, here I am inserting each document separately in a for loop. This is how you insert multiple files. And here you can see that we have created for all of them, which means that we were able to index the 3 documents, and they were all split into 2 shards. Finally, we can show the mapping that was done automatically by Elasticsearch with this getMapping method. Let me run this. For example, created on was considered as a date field. And for text and title, both of them was considered as a text field. So for most of the time, Elasticsearch does a good job identifying the type of each field. But if you want to do this manually for any reason, you can do that. But this only works when creating the index. So before inserting the documents, you need to specify the mapping while creating the index. So here, as you can see, you can either pass it inside this create method if you want. So you can see that you have mappings, or you can do that later if you did not add any documents. Okay, so here I have this mapping objects. Inside of properties, you specify the data type for each field. For example, created on is set to date. Text is set to text, etc. And after that, you use the put mapping to add the mapping manually. And here, if I print the mapping, you can see that it is the same. And as I told you, if you want to add this directly in the create method, you can do that. Here I am deleting the index, and while creating it, I am passing the mapping instead of using put mapping. But both of them works, and all you need to know is this should be done before inserting the documents, and ideally when creating the index. And for me personally, I don't like this approach, which is the manual mapping, because it is more involved, but in some cases it might be needed. We arrived at the end of this video. I hope that it was helpful and that you learned something from it. Please don't forget to like this video, leave a comment, and subscribe to the channel. See you next time. Hello everyone. This is video number 5 in this series. Today I will talk about the field data types. Remember, when indexing files in Elasticsearch, we have a process that is called mapping, which can be done either manually or automatically. During the mapping phase, Elasticsearch tries to figure out the data type for each field in the document. In this example, we have 3 fields, and here are the data types. I will start by showing you the common data types, and in each slide, I will be referring to the documentation to learn more. To get the slides, you can find the link in the description. You will be redirected to my GitHub repository. There you can download the slides for free. In this category, we have the binary data field, which accepts a base64 encoded string. This field is not searchable and is not stored because simply the base64 encoding is too expensive to store. So what do you do if you want to retrieve data? Well, you use the underscore source key to retrieve the document, and after that, you can get the binary value and decode it. Here is an example of how to use this field. Let's say that you have an image. First, you encode it to get the binary representation, and after that, you index this encoded string. Alongside the binary data field, we have the Boolean data field, which is very simple. You store true or false values. We have numbers. They can be long, integer, byte, short, and others. We have dates, and finally, the keyword data type. You will use the keyword data type if you want to filter or sort the documents, because as you can see, the use case for the keyword data field is when you have IDs, zip codes, etc. Now, before I move to the other category, I will stop and go to the notebook to show you how to use the data types that we have seen for now. So here we are going to use this notebook. You can see that once again, I am referring to the documentation. The first step again is to connect to Elasticsearch. And here's how you use the binary data field. Here I am creating a new index specifically for this data type. And here you can see that the image data will be stored in binary format. Okay, so let me create this index. And here I am just taking an image. Basically, I am taking this image And I'm using the base64 package to get the base64 representation of the image. And here, let me run this cell. So here I'm just printing the first 100 characters, but if I show you the length of this string, you can see that it contains well over 270,000 characters, which is very big. So this is why we don't store this kind of data in Elasticsearch, and it makes it not searchable. Because if you have 100 images, I mean, multiply this by 10 or even more, it depends on the size of images, and you will get a very heavy number of characters stored in your database. So after that, we construct our document and we use the index method that we have seen in the previous video. So insert this document into this index. Okay, so let me run this. And as you can see, the result of this operation is created, which means that this document was inserted successfully. Now, quickly, let's move to the other data types. So here we have the keyword, the float. This is basically a number. Here we have the date data type, and finally the Boolean. Here, as an example, I created here a book. So here, this is the reference of a book. So this is why we are making this a keyword, because we want to, for example, after that, to filter or sort books by reference. The price should be a float number. And so here is the date, and here is our Boolean value. And we can insert this document to this index. And one more time, we have created, which means that this operation went successfully. Awesome. So now let's go back to the slides to see the other categories. Now let's move to the objects types. Here we are going to deal with JSON data. The first data type in this category is the object data type. To demonstrate the use of this data type, I have here an example. Consider this JSON object. When indexing it, it will be stored like this. You can see that instead of having nested objects, we will use the dot notation to represent each value for this nested JSON. So after that, if you want to, let's say, get the age, you will use manager.age and then specify the value. This is one way of indexing a JSON object, but we have other data types in this category, like the flattened object. You will use this one if you are dealing with deeply nested JSON objects. Otherwise, stick with the object's data type. But the problem with the flattened object is that you lose the hierarchical structure. I will show you what this means later in an example. We also have the nested data type. This one is used when you have an array of JSON objects. And the great thing is that this type preserves the relationship between fields. Now, here is the example that I was talking about. Say that you have this JSON object. You can see that the user contains an array of objects. While indexing it, it becomes like this. If you use the flattened data type, you can see that we lost the relationship between fields. Before, we had Alice Wise in the same object. But now, if we try to get this person's first and last name, we won't be able to do that because they are not aligned in this array. The problem, though, will be solved if you use the nested object data field. So in the nested data type, you would have Alice and here you will have White. And this will preserve the relationship between your fields. Now, before I move to the other category, let's go back to the code to see how to use these data types. So in the same notebook, I have the object types. Here, this is how we use the object data type. You can see that we have basically a JSON file with two keys, first name and last name. And both of them are type text. We will see this in the slides. Don't worry about it. Okay, so we created the index. And here, so this is my document. So an author contains the first name and last name. So when running this, so it says created. Great. So we indexed the values inside this index. And in a later video, I will show you how to search or get documents. So don't worry about this for this video. For the flattened version, so it's simple. So you take the same author document and here you just specify flattened, and Elasticsearch will do the job to convert the document into a dot notation. Okay, so let's create the index. We have the same author. Basically, we have the same document, but internally it will not be saved the same way if we have used data type or flattened or even nested data type. Okay, so let's move to the last data type, which is nested. Again, so here the only thing you do is to change this from flattened to nested. But for nested, you need to make sure that you had an array of objects. Okay, so let's create the index and let's index our documents. So here, remember, you have a set of documents in your documents. And here, basically, you can see that we have these objects, and the nested data type will make sure to preserve the relationship between the fields. So John Smith will be preserved instead of being thrown out randomly. Okay, so this is what I have for you for the objects data type. Now let's go back to the slides. Now we are going to talk about the text search types. The first data type in this category is text. We can use this data type to store a string of text, but this is different than using the keyword data type because the text data type is optimized for search. For example, you can take the body of an email or the description of a product and store it. But when you do that, so let me show you this example. Let's say that this is the description of a product stored in this document. And if you specify this field to be stored as a text data type, Elasticsearch will try to analyze the document and optimize it for search. We also have the completion data type, search as you type, and the annotated text. You can see that I am going quickly on some data types, but don't forget, you can always refer to the documentation. Just click on this link and there you can read more about each data type separately. So this is what I have for you for this category. Let's go back to the code and let's see how to use them. Okay, so 3 text search types. This one is going to be easy. So here I am creating a text index. Let's say that we have a set of documents that have the email body. You will store that as a text. Okay, so let's create the index. Cool. And here's our document. It has just one field, the email body. Let's insert it. And great, it works. For the completion, you will use, here you need to use this suggest. Basically, for each document, you'll have a set of inputs. So if you are typing Mars, it's going to give you, if you are typing, for example, NA, it will give you Mars, because this is the closest completion to what you were typing. And here, you basically you have a set of documents, and based on what you are typing, Elasticsearch will try to analyze the text that you have written and the inputs that you gave it in each document. And after that, it will give you the closest match. So let's create the index. So here we have our documents, and basically you use the index method to add them like this. And here we have created, which means that everything went well. Finally, in this video, I will talk about the spatial data types. We have the geopoints data type. You use this to store the, for example, latitude and longitude of a point. We have the geoshape. This is used to store complex shapes like this. Here you will have a list of points as the field. And we have other options such as the points and the shape data types. This one was quick, but let me show you how to use that in code. Okay, so we arrived at the last section. Let's expand this. So let's start with geopoints. Again, here you have the location. It is set as geopoint. And as I told you, for geopoint, you specify the latitude and longitude. you can do it like this. So you put the values inside an array and you specify that this is a point, because Elasticsearch will determine that, okay, so this is a point, which means that this should be the latitude and this should be the longitude. And when inserting this, it gives us created. For geo shape, it's the same. So you have the location. So this is just an arbitrary name, but what matters is this. So when you specify geo shape, you need to pass a list of points. For example, here you have, this is the first point, this is the second point, and it's going to create a line, because to draw a line, you need at least 2 points. And for a polygon, you will have a set of points. And when you work with complex shapes, you need to make sure that the shape is closed so that this works. Okay, so we have the first document, which is just a line, but here we have a polygon. And we can insert both of them like this. And here I'm showing you how to use points again. So it's similar to GeoPoint, but you just specify that here it should be points. And yeah, this is how you work with spatial data types. That was a lot. I hope that this video helped you know about the diversity of data types that Elasticsearch supports. I am once again linking to the documentation because it is the best place to learn about field data types. Thank you for watching. Please like this video, share it with your friends, and subscribe if you like. See you next time. Hello everyone. In this video, I will show you how to delete a document from an index in Elasticsearch. Let's demonstrate how this works by showing you an example. Say that we have an index called myIndex. Inside this index, we added 3 documents. Each document is assigned a unique ID. The delete operation expects 2 arguments, the index where the document that you want to delete exists, and the ID of that document. If we give the delete operation myIndex and the ID number 1, then this operation will successfully delete that document from the index. On the other hand, if we provide the delete operation with an ID that does not exist, it will throw an exception. This is all you need to know about the delete operation. But if you want to read more, check out the docs from here. Now let's see how to delete documents in Python. Make sure to open this notebook. You can see that once again I am pointing to the documentation. Click here to read this if you want. First of all, we need to connect to Elasticsearch. Make sure that the Docker container is running. After that, here I am creating an index, as we already do. Here I am using that dummy data just to load some documents and insert them to this index. Here I have only 3 documents and here are the IDs, okay? So I made sure that I stored the ID for each document because I will be using it later. Okay, so this is just a preparation. Now let's see how to delete documents. So the first example shows you how to delete documents successfully. Here you can see that we use the delete method and we give it 2 arguments, the index as well as the ID. Here I am taking the first document or the ID for the first document and I am using it to delete it. So if I run this cell and the cell after it, you can see that here it says that the result is deleted, which means that we were able to delete this document with no problems. The second example shows that if you specify an ID that doesn't exist in the index, it will throw an exception. So here I am using the try except block to catch that exception. And as you can see here, it says that the document was not found. We arrived at the end of this video. I hope that it was helpful. Please don't forget to leave a like and subscribe to the channel if you like. See you next time. Hello everyone and welcome back to the channel. In this video, I will show you how to get a document from an index in Elasticsearch. Let's demonstrate how this works by showing you an example. Say that we have an index called myIndex. Inside this index, we added 3 documents. This is the same as the previous video where we talked about delete arguments or the delete method, and you are going to see that it is very similar to it. Remember that each document has a unique ID. Now, the get operation expects two arguments: the index where that document is stored and the ID of the document. If I give these two arguments, which are my index and ID equal to 1, this operation will get me the first document. On the other hand, if I specify an ID that doesn't exist in the index, for example 4, again, the operation will return an error saying that the document was not found. That's all you need to know about the get operation. But if you want to dive deeper, I highly suggest you to click on this link to read the documentation. There you will find everything you need to know about the get operation. Now, let's see how to do this in a notebook that I have prepared. Make sure to open the 7th notebook in this series. Again, if you want to read the documentation, please click on this link. But if you are ready to start, then make sure that the container is running so that you can connect to Elasticsearch. After that, here I am doing the same preparation that we did in the previous video. I am just taking that dummy JSON file and I am inserting 3 documents into the index. And as you can see, here we are keeping track of the IDs so that we can use them in the get operation. Okay, again, we have 3 examples. One that shows how we can retrieve documents successfully, and the other one shows you that if you want to retrieve a document with an ID that does not exist, you will get an exception. So here I am taking the first ID, and here if I look at the response, you can see that here I am getting the document. So if you want to get the document back, just use the source key, and this will get you the JSON that you have inserted. But if we try to give an ID that doesn't exist, again, we get a not found error exception. We arrived at the end of this video. I hope that this was helpful. Please, before you leave, if you want, leave a like on this video and subscribe to the channel. This will help me a lot. See you in the next video. Hello everyone and welcome back to this video. In this one, I will show you how to count the documents that you have inserted into an index. Again, I keep talking about this my index example, but bear with me. You will understand what I will show you in this video. Let's say that we have inserted some documents to this index, but we forgot how many documents we have in the index. To be able to count the documents, we use the count method. This method receives one parameter, which is the index. Okay, so when we feed the index to this method, it gives us the number of documents. We can also provide this method another parameter, which is called the query. This parameter is used to match certain criteria. For example, if you want to search for a specific word in all the documents, this method will return you that number of documents that has that specific word. That's all I had to show you about the count documents in this video. If you want to read more, please make sure to click on this link. Now, let's go to the code to show you how to use this functionality. Make sure to open the 8th notebook. Here, as you can see, first you need to connect to Elasticsearch. After that, we are creating the myIndex index. Here again, we are using that dummy data JSON file to insert 3 documents. And as you can see, to count the documents, we can use the count method. Here we are providing the index, and in the response object, we can access the count value. And if I run this cell, it says that the number of documents in the index is 3, which is correct. And here is an example that shows you how to use the query. Here you can see that we have some specific things related to date, because here I am searching for a specific document that has this value. So let me show you what I'm talking about. If we look at the dummy data JSON file, you can see that I have a field which is called created on. This is going to be mapped into a data field. And when searching or when making a query, we have some specific terms that we can use for data fields, like range, greater than or equal, and less than or equal. Don't worry about this. I will talk about this in details in the search API in one of the upcoming videos. So here, basically, I am searching for a document which has the value 2024-924. Okay, and here it returns me 1, which is correct. If I go back to the dummy data JSON file, let's put it aside. You can see that we had just one document with this value. Now, if I change this and put 24 again here, and let me run everything. Okay, so here it gives you 0 because it needs some time to index the files. But if I run it one more time, you can see that now it says that we found 2 documents with this value in the created on field. We arrived at the end of this video. I hope that it was helpful. Please, before leaving this video, make sure to leave a like and subscribe to the channel if you like. See you in the next video. Hello everyone and welcome back to the channel. In this video, I will talk about the Exists API. This API is very useful. You can use it to check if an index exists in Elasticsearch or if a document exists inside an index. So let's show how this works with an example. Let's say that we have 3 documents. We are going to insert them in this my index. Here, if you want to check if the index exists, you need to use this. So you take client, then you take indices, and you use the exists method inside that module. This one checks, it takes in an index, and it checks if it exists or not. But to check if a document exists inside the index, you just use this. You take the client and you use the exists method inside the client. But here you need to specify 2 things, the index and the ID of the document. Okay, so this is what I say. This method checks if a document exists in an index. Okay, so this is how you use the Exists API. And one more time, please check the documentation to learn more about the Exists API. Now, let's go back to VS Code to see how to implement this. Okay, so open the 9th notebook in this series. If you are wondering where to get these notebooks, you can find the link to the repository in the video description. So please go there and clone the repo or download it to get access to the notebooks. First of all, we are doing some processing. We are taking some documents from a JSON file that you will find in the repository, and we are inserting everything into this my index. Okay, here we have document IDs because we need that in order to check if a document exists or not. So let me run the first cells. And as you can see, here are the document IDs. Great, so that was just a preparation. Now let's see how to use the Exists API. First of all, to check if the index exists, you use, as I said, use the client, then indices. Inside indices, we have the exists method. This one only takes in the index name. Okay, so here I am giving it my index, and here it returns to me true, which is good because we created that index before. But if I gave it something else, let's say my index 2, you can see that here it returns false because we don't have this index in Elasticsearch. Okay, now to check if a document exists, we can just use the client because inside it we have another exists method. But this one takes in 2 arguments, the index as well as the ID. So here we are checking if this document exists inside my index, and the response should be true. But if I do this and provide an ID that doesn't exist, it returns to me false. We arrived at the end of this video. I hope that it was helpful. Please, before leaving, leave a like on this video and subscribe to the channel if you want. That will help me immensely. See you in the next video. Hi everyone. In this video, I will walk you through how to update a document in Elasticsearch. The Update API in Elasticsearch works whether the document already exists in the index or if you want to insert a new one. Let's start with the first scenario. Imagine we have an index containing 2 documents. The update method requires 2 main parameters, the index name and the document's ID. Internally, the update method performs 3 operations. It retrieves the document, it modifies it, and finally, it reindexes the updated document back to the index. So how do we perform an update? Let me show you an example. Say we have a document with two fields, book ID and book name. We first insert this document into the index. This operation assigns the document a unique ID. Next, we use the update method with myIndex and ID equal to 1 as inputs to retrieve the document. This is the first step in the update process. To make changes, we use a parameter called script where we specify the field we want to modify. For example, let's change book ID to 2. Once we pass this script parameter to the update method, we can modify the document. This is the second step in the process. Finally, the updated document is saved back into the index, completing the third step of the pipeline. This is a simple example, but you can do much more. For example, you can add or remove fields, insert items into fields, and more. We will explore additional examples in the notebook. Now, what happens if you try to update a document that doesn't exist in the index? For instance, we still have the same two documents in the index. But what if I try to update a document with an ID that does not exist? You can see that here I am trying to update the document which has ID equal to 4, but this document does not exist. In this case, the update method can create a new document with the specified ID. All you need to do is provide additional parameters, such as the JSON content and set doc as upstairs to true. If you do these things, the update document will work like a create method or a index method, and it will add this document to the index. That's a quick overview of how the update API works. I have covered the two main use cases, but if you want to explore further, be sure to check the official documentation. Now, let's jump into the notebook to see the update API in action. Open the 10th notebook in this repository. You can see that here you can click on docs to read about the update API in details. First of all, we need to connect to Elasticsearch. Here I am I'm creating a new index and I'm inserting 3 documents, which comes from this dummy data JSON file. If you don't have these notebooks, please go to the description, click on the link that will take you to GitHub and download or clone the repository. There you will find everything. Okay, so that was a preparation. Now let's start showing you how to use the update API. So as I said, we have 2 use cases. So here, if the documents exist in the index, what we can do, we can take, for example, a document and update an existing field. First of all, let me just open the dummy data file and put it here. You can see that here, by default, the title is sample title 1. So here, what I am doing, I am taking the first document, which is this one. And here, as I told you in the slides, you need to use the scripts parameter. And inside it, here you specify the new value for the title. So here, parameters allows you to change the field dynamically, which means that you can reuse these values inside the script. But you can just come here and type in the new value if you want. So here you can see that context.source will get me the document. And after that, when I can take the document and access the title, this is what I am doing after that. And here I am passing the new value, which is new title. So let me run this cell. And as you can see here, if I take response and try to use the get method, which I showed you in a previous video, you can see that here the new value for title is new title instead of sample title 1. Okay, so this is the first use case. But you can add, for example, new fields that doesn't exist in the documents. So here again, I am taking the first document, and here I am adding a new field, which I called new field, and I am giving it this dummy value. Let me run this. Again, let's use the get method. And as you can see, so we have we have our new field, and we have text and title, which already exists in the document. You can add a new field by using the script parameter or by using doc. Both of them do the same thing. So let me just run this, and as you can see, we have a new field which I called new value 2. And you can either use doc or scripts. They will work together. So I showed you how to modify a field, how to add a field. Now let's see how to remove a field. It's simple. You just use context.source, and here you have a method which is called remove. And inside it, you specify the field that you want to remove. Let me run this. And as you can see, so here we removed new field. And as you can see in this source document, we don't have that field. Okay, so that was the first use case. The second one is where you don't have the documents in the index. So here you can see that ID equal 1 does not exist. If I take the document IDs list, you can see that here are the IDs for the documents that are already in the index. Okay, so here, as I told you in the slides, if you want the update method to create this document, you need to specify doc as upsearch equal to true, and you need to provide it with the JSON data. So here we have both of them. And if I do this, you can see that the response says created. But if I go back to the first use case, you can see that the updates method gives us updated because we already had that document in the index, so it will just update it. But in the second case, because that document was not in the index, it says created. And let's just verify by using the count method. And sure enough, it shows us 4, which means that we already have the 3 documents that are inside dummy data.json, and we added the 4th document thanks to the update method. We arrived at the end of this video. I hope that it was helpful. Please, before leaving, leave a like on this video. Subscribe to the channel if you like. See you next time. Hi everyone. In this video, I will walk you through how to use the bulk API in Elasticsearch. Let me show you an example of how the bulk API works. Normally, if you have an index and want to add a new document, you would perform the index operation. Here I have 2 documents, and I will perform the index operation for each one of them. You might also update or delete documents along the way. Each of these operations requires a separate API call, which means the more operations you perform, the more API calls are made. This can become inefficient when dealing with a large number of operations. That's where the bulk API comes in. Instead of making multiple individual requests, you can bundle all operations into a single API call, significantly improving processing speed and reducing overhead. Let's take a look at the syntax for the bulk API. When using it, you alternate between specifying the action to be performed and providing the corresponding source. Okay, so as you can see, this is a process where you alternate between the action and the source. The available actions include indexing, creating, updating, and deleting documents. However, not all actions require a source. Only the update, index, and create actions need one. Now that we have covered the theory, let's look at a practical example of using the bulk API in Python. First, you will use the client to access the bulk method. Inside this method, you will pass a list of operations where we alternate between actions and sources. The first action we will perform is index, which requires a source, so we'll provide it right after the action. Next is the delete action, which does not need a source, so we move on. Then we use the create action followed by its source. Finally, we have the update action along with its corresponding source. As you can see, the syntax is straightforward. Just alternate between actions and sources, remembering that some actions require a source while others don't. For more details, you can click this link to access the official bulk API documentation. Now let's go to the notebook to see how to apply the bulk API. make sure to open the 11th notebook in this series. Let me remind you, if you don't have access to these notebooks, please go to the video description. There you will find a link that will take you to GitHub, and feel free to download the GitHub repository. There you will find everything. First, please make sure that Elasticsearch is running. To make sure that everything is working, just run this cell, and here it should say connected to Elasticsearch. After that, here I will show you two sections. The first one, I will try to perform some actions without using the bulk API. And in the second part, I will show you how to transform these actions by using the bulk API. Okay, so let's start. First of all, we have this dummy data JSON file. Inside it, we have 3 documents. So we will be performing the index operation 3 times. After that, I will update 2 documents. I will update the first one by modifying the title field to add this new value. And I will modify the second document by adding a new field to it. Finally, I will delete the third document. In total, we have performed 6 operations, and each one of those operations require a API call. This approach is slow and inefficient, especially if we are dealing with very large number of documents. So this is how to do this without the bulk API. But let's see how to transform everything with this API. I'll make sure to recreate the index, and here, as you can see, so first of all, we have the first action, which is index. You can see that here I am using my index, and here I am specifying an ID. After that, I am taking, basically, if I go to dummy data, you can see that I took the first document and I specified it as the source, because remember, the index method requires a source. I do the same thing for the other documents. Just make sure that the ID is unique. So here I will try to index the second document. That's why I gave it ID equal to 2. And here is the source. Finally, I am indexing the third document in the third action. After that, we will update 2 documents. First, I will update the first document by changing the title to a new title. And for the second document, I will add a new field with this value. Finally, here this should say action 6. I will just delete the third document. If I run this, you can see that we have a key which is called errors. If this value is false, it means that the bulk API was able to perform all those actions with no problems. But if you get true, this means that some or all the actions did not perform successfully. And here it gives you how much it took in milliseconds. And if you want to read more, you can look at the operations. Okay, so here it says created. Good. So we created the first document. The same for the second and third documents. And here we have the update documents. So here it says updated with status equals to 200. And finally, we have deleted. This just confirms that the bulk API was able to perform all the operations successfully. We arrived at the end of this video. I hope this was helpful. Please, before leaving, leave a like on this video. Make sure to subscribe to the channel if you want. See you next time. Hi everyone. In this video, I will show you how to use the search API in Elasticsearch. In the previous videos, we have seen how to create an index, add documents, update them, and delete them if needed. But how do we actually make use of these stored documents? The answer lies in the Search API. This API allows you to leverage the indices you have built to create things like search engines, recommendation systems, real-time dashboards, log data analysis, and much more. Since the Search API is extensive and offers a lot of features to explore, I will be breaking it down into several videos. The search method accepts several arguments, with the index argument specifying where Elasticsearch should search for documents. You can provide a single index like my index, but to search across multiple indices, separate them with commas. For example, index 1, comma, my index. You can also use wildcards to match multiple indices without listing them individually, such as index asterisk. This will match any index with this specific prefix. So if you have index_1, index_2, instead of typing them like this, you just use the wildcard. Or to search all indices, use _all. The search method also utilizes queue and query parameters to define how searches are performed. But let's start with the queue string. This one, you use it for simple searches with loosening syntax. We will see this in one of the upcoming videos. And here we have the query. This one, it's like the queue string, but this is used to make complex structured queries. And it uses the query domain-specific language. We will see this again in a later video. In addition to the index, queue, and query parameters, the search method supports additional arguments such as timeout, size, and from. Timeout specifies the maximum time to wait for a search request to complete. The time unit can be seconds, milliseconds, days, etc. If you want to read more, please click on this hyperlink. Now let's go to size. This defines the number of search hits to return. The default value is 10, but you can adjust it if you want, but remember that the maximum value is 10,000. Finally, we have the from parameter. This indicates the starting point from which to return search results. You use this for pagination, and it is useful for implementing skip functionality in result sets. This is the first part of the search API. If you want to read more, please click on this link. Now I will go to VS Code to show you how to apply some of the things that we have seen in this video. Great. So please open the 12th notebook in this series. Remember, to download all these notebooks, go to the video description. You will find a link that will take you to my GitHub repository, and feel free to clone it or download it. So here for the documentation, we have two links. We have the search API and the search API. So it's kind of misleading, but please, if you want to read more, click on them to find everything about the search API, because it has a lot of things that supports. And it's because the search API is one of the most important things to learn about Elasticsearch. Great. So make sure that Elasticsearch is running. Here I am creating two indices and inserting the dummy data documents in both of them. Great. So that's the preparation. Now let's see how to search for. So here you can see that we can search for documents, and we are specifying the index and the query. Great. So first of all, we are using index1, and here the query, you use the body, and inside it you specify either query like this or queue. But here I'll just keep it query. Why am I doing this? Because by default, this is the value of query. It matches everything. But if you want to make specific queries, you should change what is inside this dictionary. So if I remove this, it will give me the same result. So here it says it found 3 documents. Let me undo what I did. And if I run the cell, you can see that it still gives me 3 documents. And here, as I told you in the slides, Elasticsearch will return something called hits. Hits means a document. So if I print the response just to show you how this looks like, let me go to hits. You can see that here we have 3, which means that we got 3 documents. And here, let me go inside hits again because we had this. So we can see that here we have the documents. And if I want to select the first document, all I need to do is get the first element in the list. And then you can see that here we have something called _source. Now, if I print this, you can see that we get our documents back. Okay, cool. Let's do the same thing for index2 just to verify that we have 3 documents. Nice. That's what you want to see. Now let's see how to search for documents in more than one index. As I told you, if you want to do that, just make sure to separate the indices by comma. So here, instead of returning 3 documents, it returns 6 documents. If you want to use a wildcard, you can do that. Remember, here we have index_1, index_2. So the prefix, which is common between these 2 indices, is index. If I run this, you can see that I get, again, 6 documents. If you want to return all the documents in all the indices that you have in your Elasticsearch cluster, you use _o. And this returns 6,400 documents because I have other indices in my Elasticsearch cluster. We arrived at the end of this tutorial, but remember, this is a 3-part series where we are going to discover the Search API. Please, before leaving this video, leave a like and subscribe to the channel if you want. See you next time. Hello everyone, welcome to part 2, where we continue exploring the Search API. In the last video, we discussed that when searching for a document, you need to specify both the index and the query for the search method. To build more advanced searches, we use the query DSL, domain-specific language. As mentioned before, query DSL helps create complex, structured queries. There are 2 main types of clauses in query DSL, leaf clauses and compound clauses. Leaf clauses target specific values within specific fields, such as match, term, or range queries. These queries can stand alone, which means that you can use, for example, just the match query or just the term query. But the compound clauses combine one or multiple leaf or even compound queries and allow for more complex logical combinations. So here you use bool. So for example, you can combine match and term, can combine multiple matches, etc. We will see some examples in the notebook. Let's dive into the leaf clauses. Let's start with the match query. Here you can see that it is in blue, which means that you can click on it if you want to read more in the documentation. The match query performs full text search and returns documents that match a given text, number, date, or even a Boolean value. If you want to use match, then the field must be mapped to a text data type. The term query returns documents that match an exact term in a specified field. The field should be mapped as a keyword or to a numeric/date type. For example, if you want to use term, you use it if you want to search for a book ID or a username or an email. These are values that are not repeating and you can consider them as keywords. Finally, we have the range query. This one returns documents where a field's value falls within a specific range. Now let's see some examples that shows you how to use these queries. Let's start with the match query. As I told you, you use the search method, you provided the index, after that you specified the query. So inside the body arguments, you pass the query, and inside the query we have specified match. So here we are using the leaf clause. Inside match we are matching this text. So we are taking the field description and we are searching for any document that matches what we have here. So we have a description, which means that any document that contains this string will be returned. For term, it's the same thing. You just swap match with term, but this time make sure that, for example, product ID is mapped as a keyword data type. And here, for example, we will return any document that has this string. Finally, the range query is a little bit complex. I mean, it's not complex, but you just need to add more things. So here you see you used range, you specify the field, and here you have this means greater than or equal and less than or equal. To find these values, you just need to go to the documentation. There you will find what the range query expects. Now for the compound clauses, we have the bool query. This one combines multiple queries using Boolean logic. So here we have must, filter, should, and must not. This clause is used with fields mapped to a text data type. Let's see some examples to show you how to use this compound clause. Okay, so this one will be bigger because we will add a lot of things. Because as I told you, the Boolean query allows you to make complex queries by combining multiple, for example, leaf clauses or even compound clauses. Okay, so inside the query, so here, as I told you, use the search method, provided the index and the query. Inside the query, we will use the Boolean query, which is the compound clause. Inside it, we have must. Inside must, we have the first query. here we are matching any document that has Elasticsearch in the title. After that, we are filtering any document that has the status as published. Here we are using should, and finally we have must not. Now let's explain all these terms. So must, here we are trying to keep documents web title is equal to Elasticsearch. So must, it's like and in logic. Filter here, filter, basically you will remove any document with a status of published. Should, this match is optional. So if a document matches this, that's good. If it doesn't, no problem. So should is an optional option. Finally, we have must not, which means that we are excluding any documents where the deleted is true. Okay, so you use must, filter, should, must not to combine between all your queries. And here you can see that, for example, must, we have an array. So you could have inside must multiple matches, or you can have inside must match term and range. So you can make some complex queries. Here I am just showing you the individual components, but you can use them however you like. Okay, so this is all the things that I wanted to show you in the slides. Now let's go to the code to see more examples. Okay, so open the notebook number 13. Here you can see we have the documentation, and here I am pointing you to the query DSL language, because this is what we will use in this notebook. First of all, try to connect to the cluster, then insert some documents to the index. So here I am inserting those documents that are inside the dummy data JSON file. Great. So now let's do the search. So here I will start with the leaf clauses. Remember, here I am starting with term. And to use term, so here you can see that we are searching for a document that was created on 2024-9/22. And here you can see that we have just one document. Let's just verify if this is correct or not. So I have my dummy data JSON file, and as you can see, that's correct. So we have just one document that was created on this specific date. So here you can see that we have this hits dictionary that contains how many documents that we found. So here we have one, which is correct, but to get the document, basically you use hits again, which will return you a list of documents. Okay, and as you can see inside the source dictionary, we have our documents back. So it matches the documents that we have in this JSON file. Great. So you can see that here with term, we are looking for exact values, but to do full text search, you use the match query. So here you can see that it's simple. You just swap term with match. And here you need to make sure that the field that you are searching for is mapped to a text data type. Great. And here we are searching for any documents that contains this string inside the text field. And as you can see, if I take this and search for it here, you can see that we have 3 results. And each one of the 3 documents contains this string. This is why we get 3 back. And again, you use hits to get your documents. Okay, so we have the first one, this is the second one, and this is the third one. Now let's move to range query. Okay, so here I am filtering the documents, and here I just want to get the document that is less than or equal this value. Let's see. So here we have only one document that is older than this value. This is why we get 1 back. But let's do 25. This should give us 3 documents. Great. Okay, so we have seen this. Cool. I hope that this is very easy for you guys, because you can use these leaf clauses individually, but here I am saying that this is how you use the leaf clauses. But if you want to combine multiple leaf clauses to make complex structured queries, you need to use the compound clauses. And this is what I will show you in the second part. So here I am showing you an example. Let's search for documents that meet the following criteria. Created on this date and have the word third in the text field. To use the compound clauses, you just specify inside the query that this is a boolean, which means that we will combine between multiple queries. First, inside must, I told you that you have an array, and inside it you can put multiple leaf queries. The first one is match. We want to match this string. And for range, here we said that it should be created on that specific date. And here we are greater than equal and less than equal this should have the same value. And this should return us just one document. Let's verify. If we search for third, you can see that third exists in just one document. But 2024 exists in two of them. But because we have these two leaf clauses inside the mass, here we are going to make a NAND operation, which means that both of these queries must return a document. So if this one returns a document, but this one does not return a document, or if it returns a different document, then we will return nothing. But if both of them return the same document, we will count it as a valid document because it matches all the criteria that we have specified. Okay, so this is a simple example, but again, you can add as many leaf queries or as many compound clauses inside the bool dictionary to make more complex queries, as I said here. With the compound clause, we were able to combine two leaf clauses to find a specific document. And this is the power of using compound clauses. We arrived at the end of this video. I hope that it was helpful. Please, before leaving this video, leave a like and subscribe to the channel if you like. See you next time. Hello everyone. Welcome to part 3. Today, we will continue exploring the search API. I will show you how to use important parameters like timeout, size, from, and aggregations. Let's start with the timeout parameter. Timeout sets the maximum duration for a query to execute. If the search takes longer than the specified time, Elasticsearch will abort it and return partial results. Next is the size parameter. Size controls how many search results are returned. This is particularly useful when you only need a limited number of documents. Remember that the default value for size is 10, but you can change it, and remember that the maximum value is 10,000. Now let's talk about from. This parameter is used for pagination. It tells Elasticsearch how many documents to skip before starting to return results. Finally, let's talk about aggregations. Aggregations allow you to perform calculations on your data, like finding the average, maximum, or count of a field. That's it. These are the parameters that I wanted to talk about in this video, but remember, there are other parameters that you can find in the documentation. Now, let's go to VS Code to see how to implement them. Open notebook number 14. If you want to get access to these notebooks and all the materials, you will find a link in this video description. It will take you to GitHub, then clone or download the repository and enjoy these notebooks and follow along with me. First of all, we have the documentation. After that, we need to do some preparation. Let's connect to Elasticsearch. After that, I will insert some documents. And here, I will just use this dummy data JSON file. I have added a new one. Let's see how it looks like. So here you can see that we have a message, age, and price. This is just a dummy data just to play with these parameters. I am taking this dummy data file and I am duplicating the data just to get a big number of documents. So here I will be inserting 5,000 documents to my index. You can see, and here we will reuse something that we have seen before, which is the bulk API. Remember that the bulk API allows you to perform a lot of operations in one API call. So here we want to insert documents. So instead of inserting 5,000 documents one at a time, we will use the bulk API to do all of these operations at once. And you will see it will be very fast. Okay, so it took just 0.4 seconds. But if you try to insert one document at a time, that will take a lot of seconds to do. Okay, so that was the preparation. Now let's see how to use both the size and from parameters. Again, to use the search method, first you need to specify the index and then you specify the query. Here we are keeping it simple. We are using the default query, but here you can see that we have size and from. So size will return me just 10 documents, but from will skip the first 10 documents. And here I am returning the documents. You can see that we have seen this in the one of the previous videos. To get the document, you just use the source key inside hits. And here you can see that we have our documents. You can play with these values to see what you get. Now let's see how to use timeout. Timeout, I mean, you will not see the effects of timeout, but if you do some very expensive computation, this will become handy. Sometimes the query will take seconds or even minutes to finish. So by default, Elasticsearch will stop that query. But if you want to give Elasticsearch or your query the time needed to fetch the data, then you can specify that number here. So use timeout, and here you specify 10 seconds or minutes. So you can change the time units. You can find this information in the documentation. Okay, so we are doing the same thing. Here we are searching for any documents with search keyword in the message field. And remember, here we are using match. So we have seen this before. And we are trying to, do textful search in this case. So here, everything went well. We have returned how many values? 5,120. And 10 seconds is more than enough to make or to return these documents. Okay, now let's see aggregations. Aggregations, as I told you, will allow you to make calculations over any field that you have in your documents. You can see that in order to use aggregations, you need to use this keyword, and inside this, you'll, for example, here I want to calculate the average age, so I will give it this name. Here, you tell Elasticsearch which method to use. If you want to use average, you type in average. If you want to use sum or max or min, you need to put that value here. And here I am telling Elasticsearch which field to use. Here it returns me 31.6. This is the average age that I have in my documents that I inserted to the index. And basically, to get the value, you access the aggregations dictionary. Inside it, you use the same name that you have used here, and you get the value. Finally, if you want, you can combine these parameters together to make a specific query. Okay, so here we are using this. So we are trying to match any document with important keyword in the message field. After that, we are calculating the maximum price. So before we have seen how to calculate the average, now we are using max over the price this time. And here I just want to get 5 documents, and I am skipping the 21st documents. And finally, I have timeout set to 5 seconds. If I run this, you can see that I am getting back 5 documents, and I am getting the maximum price. If you look closely, here we have the maximum price in the returned documents is 180. But if you use aggregations, Elasticsearch will not use these 5 documents. No, Elasticsearch will use all the documents that are present in the index to do the calculations. If you want to, for example, here we are calculating the maximum value. To do that, Elasticsearch will take all those 5,000 documents that we have inserted and will search for the maximum value. I hope this makes sense. So this is an example that shows you how to combine between all these parameters. We arrived at the end of this video. I hope this was helpful for you. Before leaving, please leave a like on this video and subscribe to the channel. See you next time. Hello friends. In today's video, we will be discussing the dense vector field type. A dense vector is used when dealing with a vector of numeric values. Dense means that the vector is mostly filled with non-zero values. You should use this field type if there are few or no zero values. Note that dense vectors don't support aggregations or sorting, and storing multi-dimensional vectors is not possible. To retrieve the closest vectors, we use KNN search, which we will cover in a future video. Also, remember that the maximum size for a dense vector is 4096. Now let's look at some examples of how to use the dense vector field type. In the first example, we use the index method to pass the index, document ID, and the document itself. Here the document has 2 fields, a text field, and a dense vector field. As you can see, working with this field type is straightforward. You just pass in the array of values. In the second example, we show that indexing fails because we are trying to store a matrix instead of a vector. This operation is not supported by the dense vector field type. It's important to note that when using the dense vector field type, you must manually define the mapping. Elasticsearch cannot automatically infer the mapping for vectors, as it requires details like the exact number of dimensions in advance. In a previous video in this series, we covered how to set up the mapping. Here's an example that shows the creation of an index with two properties, size length and shape. The size length is defined as a dense vector with 4 dimensions. You can also provide additional parameters to size length, which are available in the documentation. The second field, shape, is defined as a keyword, but this is not important in our case. Before moving to the notebook, please, if you want to read more about the dense vector field type, check out the documentation. Now let's go to VS Code. Open the notebook number 15. If you want to read more about the dense vector field type, click here to go to the documentation. Make sure that Elasticsearch is running and run this tab. Great, so we are connected. Now, as I told you, when creating the index, we need to do the mapping manually. And here I am showing you the same example that we have seen in the slides. Here I have two fields, and size length should be a dense vector with 4 values. So the dimension here is set to 4. After that, when indexing documents, all of them need to have 4 values. You cannot index documents with variant sizes of vectors. That will not work. Okay, let's create the index. And now here I have 2 cases. The first one, which showcases the padded case. This is how you use the dense vector. Here I am trying to index a document. So shape is square and size length, as you can see, contains 4 values. If I run this, here I get successful and it shows me that that document was created. Great. Now let's see the mapping just to verify that it is the correct mapping. And sure enough, you can see that size length is a dense vector. And you can see that the dimension is set to 4. But we have other parameters. This is what I talked about in the slides. For example, here we have similarity, which is set to cosine. This is going to help us retrieve the documents. We have other values. We can, for example, set it to dot product or other metrics. And if you want to know how to use these parameters, please just check the documentation. There you will find everything you can customize about the dense vector field type. The second case, which is the invalid case, this is simple. You can see that here, instead of indexing a document with a vector, I am trying to index a document that contains a matrix. This is not supported, and when I try to run this, it gives me an error. You can see that here it couldn't parse the object. When using dense vector, please just provide a vector and that will work. We arrived at the end of this video. I hope that it was helpful and informative. Please, before leaving, leave a like on this video and subscribe to the channel if you want. See you next time. Hello everyone. In today's video, I will be discussing the topic of embedding documents. By the end of this video, you will understand what embedding is and how to apply it to your documents. Embedding involves converting text into a dense vector. For example, if you have 3 documents with text inside them, the embedding operation will convert that text into a vector of numbers. There are various methods to achieve this conversion, one of which is utilizing deep learning models. Why choose deep learning models? The answer is that these type of models are effective because they maintain the meaning of the text and the relationships between words. You can use embedding to create recommendation systems or retrieval augmented generation. When it comes to using deep learning models, you have 2 options: closed models or open source models. Closed models are paid and operate in the cloud, meaning that the computations are not performed on your hardware. They are performed on a PC in the cloud. In contrast, open source models are free to use and accessible on Hugging Face. But if you decide to use open source models, you need to have a decent hardware, preferably a GPU, because the computations are going to be performed on your hardware. Consider the embedding size when selecting a model from Hugging Face. This parameter represents the size of the dense vector. Generally, larger sizes produce better results, with common dimensions including 384, 768, and 1024. In the image, I have included a list of models available on Hugging Face. If we click on the first model, we can see that this model converts sentences and paragraphs to a 384-dimensional dense vector. Another important parameter to consider when choosing a model is the input size, which refers to the amount of input text the model can process. If the text exceeds the model capacity, it will be truncated. Typical values for input text include 256 and 512 tokens. Again, when examining the same model, we see that here it says that by default, input text longer than 256 word pieces is truncated. So make sure to read the model card to be able to find the input size and the vector dimension. It's essential to pay attention to the language of the text, as some models are tailored for specific languages while others are multilingual. On Hugging Face, you can filter models by languages. Here in this example, I have filtered models that can convert text in English or French or even Chinese. So please make sure to select the languages here or even read the model card to learn more about the training dataset that they use. Lastly, I want to highlight this Hugging Face space that benchmarks embedding models. It's a valuable resource that allows you to select models based on their sizes. Here it says model size in million parameters. Here you can filter by the size. So here I am looking at models that are smaller than 500 million parameters. Here you can see that you can choose just open source models, or you can also include proprietary ones. And here you have multiple benchmarks, and here you can specify even the language. So if you want to check out this Hugging Face space, just click on this hyperlink. Now let's go to VS Code to see how to use one model from Hugging Face to embed the text. Open notebook number 16. One more time, I want to mention that you can find these notebooks in my GitHub repository. Just go to this video description. You'll find a link that will take you to GitHub, and feel free to download or clone the repository. Here you can see that this time I am not pointing you to the documentation, but to a tutorial that Elasticsearch created for us. And here it shows you how to use embeddings. So click on this link to read that tutorial. First of all, we need to connect to Elasticsearch. After that, here I will prepare the index. We have seen this in the previous video. To use the dense vector, you need to create the mapping manually. And in this field, we will store the embedding. So just create this index. Here, I will be using this model. Here I said, you can see that it is very popular. It has 50 million downloads in 1 month. People are using this model because it is very small, it is fast, and it provides a vector with 384 values. But if you want to go for bigger models, you can do that. I have showed you the Hugging Face space that will show you all the models that exist on Hugging Face. To be able to download this model, we use the Sentence Transformers library. So if you don't have it, please just run pip install sentence transformer and you will be able to download the model. This is the command that you need to run if you don't have sentence transformers installed on your PC. Now, because I have downloaded this model, this will be fast. But if you are doing this for the first time, it might take some time to download the model. But later, it will be cached and it will find it on your PC and it will load it quickly. And here, we are going to use PyTorch to verify if we have CUDA or a CPU. If you have a GPU, we will be using it. If you don't have a GPU, it will fall to use a CPU. Using a GPU will make the process for encoding data very fast. But because we are using just 3 documents, that will not cause any problem. Even if you use a CPU, it will be perfectly fine. And here we are taking the model and using either the CPU or the GPU. And now we are loading the documents. So we are going to use this dummy data just to show you how this works, but in a later video, we'll do a real example. The sentence transformers library makes it very easy to use any model from Hugging Face to convert or to embed the text. You just use the encode method and you provide it with the string and it will return you the dense vector. So I have this method, and here I am going to use the bulk API to make all these operations in one API call. What I want to do, I want to index the documents. So the operation that I will be using is index. And I am going to insert those documents into this myIndex index. And here, because the index method needs the document, I am specifying that after this call. And here, document, I am taking basically those three fields and I am extracting it with this notation. And I am adding on top of that the embedding. Okay, so let's run this cell. As you can see, that was very fast. And here it says created, created, created. Great. So this means that we were able to insert those three fields that we had initially. And on top of that, we were able to add another field that contains the dense vector. Now let's verify. Here I'm using query to get me all the documents that are inside my index. And as you can see, here we have the first document. It contains an ID and it contains the created on field. And here is the embedding. Here I have the text and the title. Let's make sure that the embedding or that this field is a dense vector with a dimension equal to 384. To do that, we are just going to print the mapping. So here it says, so this is the embedding field. Sure enough, the dimension is equal to 384 and the type is set to dense vector. So this is how you use a deep learning model to convert text into a dense vector. We arrived at the end of this video. I hope that it was helpful and informative. Please, before leaving, leave a like on this video and subscribe to the channel if you like. See you next time. Hello everyone. In this video, I will show you how to use KNN search to retrieve documents after embedding them. This search method is applicable only if your index contains a dense vector field. In video number 16, we learned how to convert text into dense vectors using an embedding model. But how do we search within these embedded documents? The solution is KNN search, which is specifically designed for fields mapped as dense vectors. It's important to remember that you cannot use the query parameter for this type of search. Now I will give a brief overview of the KNN algorithm. This algorithm is widely used for both classification and regression tasks. To classify a new data point, KNN identifies the k closest points to determine its classification. Various distance metrics can be used to find the nearest neighbors, such as Euclidean, Manhattan, or Minkowski distances. If you want to read more about distance metrics, please check this Medium article. Overall, the KNN algorithm is simple and effective for many applications. If you are interested in diving deeper into the KNN algorithm, I highly recommend watching this video. You are going to enjoy it. Let's now walk through an example of how to implement KNN search. When using the search method, you need to specify the index. But after that, as I told you in the beginning, we don't use the query parameter, but we use the KNN parameter. Here are the key parameters for KNN search. We have field, query vector, number of candidates, and K. Now let me explain to you what these parameters do. Field. This must be mapped as a dense vector. For query vector, this represents what you are searching for, but in vector form, not text. Be sure to embed your query. So here you can see that we are using a method that will take the text and convert it into a vector of numbers. Number of candidates. Elasticsearch will retrieve up to 50 relevant documents in this example before applying the KNN algorithm. Basically, here if you have, for example, 1,000 documents in your index, instead of using the K&N algorithm on all those documents, that will take a lot of time. So by specifying 50 for this parameter, Elasticsearch will try to analyze documents, and it will take 50 documents, and the K&N search or the K&N algorithm will be applied just to those 50 documents. Finally, we have the K parameter. This defines how many of the closest documents to the query should be returned. In this example, it is set to 10, which means that it will return the 10 closest documents to our query. Now, let's go to VS Code to see how to implement this. Open notebook number 17. One more time. If you want to get these notebooks and the slides, go to the video description. There you will find a link that will take you to GitHub. And feel free to clone the repository to get these materials. If you want to read more about the K&N search, please click on this hyperlink. First, we need to connect to Elasticsearch. Here I am creating a new index with a field set to dense vector. This is important. To use K&N search, we need to have at least one field with the data type set to dense vector. We have talked about this. Here we are going to use this machine learning model or this deep learning model to embed the text. Make sure to install the sentence transformer library. Here I already downloaded the model, so this process will be very quick. But if you didn't do this before, you need to wait for the model to download. Here I check if I have a GPU, which I have. If you don't have a GPU, this will fall back to using a CPU. And the process will be fast even if you use a CPU because we have few documents. Here I created a new JSON file, so we will not be using those dummy JSON files that we were using before. This one I had the theme. I chose to use astronomy. I like it, and here are the topics that we have. So we have a document that describes the solar system. We have black holes, galaxies, etc. So at least we have a good data set to work with. It's totally different, and it's better than using the dummy data. Okay, so here we are retrieving the documents. And here we have seen this before. Basically, we are using the bulk API to make one API call. And here the operation is index, which will take the documents and put them inside the index. And because we have text inside the content field, we will take that and convert it into a vector. To do that, we use the model that we downloaded from Hugging Face. It provides us with the encode method. As you can see, it takes in the text and it returns a vector. Let's do this. So as you saw, it was very fast. And as I told you, you don't need a GPU to be able to use the model. And here it says errors false, which means that all those operations were successful. Here, I have done this in the previous video. Here we are not using K&N search, but we are just trying to retrieve all documents to see if the embedding was done or not. And as you can see, we have the embeddings for all documents. Great. So now we can continue. Here we are again just verifying. So we are, let me remove this, or let me just make this bigger. You can see that the embedding field is a dense vector with 384 dimensions. Now we can start with K&N search. Here I have the first query. So here, this is what I want to search for. I want to search for a document that talks about black holes. So this is my query, and I need to convert it from text to a vector. This is why I am using the get embedding method. Now let me make this bigger because we will need it. You can see that we have one document that talks about black holes. So the K&N search should be able to retrieve this one instead of the other ones. Okay, so here you can see that I am using number of candidates, which is equal to 5. Here, I think I have 10 documents. Yes, I have 10 documents, but Elasticsearch will try to analyze them and retrieve 5 documents. We will take those 5 documents and apply the K&N algorithm to them to get the 3 closest documents to our query. So by just doing this, we can print how many documents we got back. Let's verify that this is working. Okay, great, it's working. Let's keep it as 3. Here you can see that I am looping through all documents, and here I am printing the title and the content as well as the score, because when using K&N search, the closest document will have higher scores. As you can see, the closest document is black holes. the score is 0.88, while the other ones are very low because they are close, but this is not what we are searching for. This is what we asked for. What is a black hole? And this document should have the answer. That's why it was the closest one. Great, so that actually works. Now for query number 2. How do we find exoplanets? Let's search for this term. You can see that we have a document that explains what are exoplanets and how do we find them. We use the transit method and radial velocity to find exoplanets. So we should expect to get this document first and some other documents in the second and third position. Let's do that. Again, I need to replace that print statement because it's not giving us the number of documents. Sorry about that. Yeah, now it says found 3 documents. Good. Let's print them. And once again, you can see that exoplanets is the closest document. For example, if you want to get just the closest document, you can replace this by 1, and here it will get you the documents. For example, exoplanets. But sometimes you would have a lot of documents that are related to your question. In that case, increase K to 3 or even 5. That will be enough. It depends on the size of documents that you have. Generally, you can play with this value. You can see that here in the end, I said that we observed that the documents with the highest score consistently corresponds to the query. But as I said, this depends. If you have the answer in one document, then the document with the highest score is the one that you should take. But if you have the answer in multiple documents, then this does not matter. You can take 1, 2, or even 3 documents and then extract the response from them. We arrived at the end of this video. I hope that it was helpful and informative. Please, before leaving this video, leave a like and subscribe to the channel. And if you have any question, please write it in the comment section. I will help you to find the answer. Have a nice day. See you next time. Hello everyone. In this video, I will show you the concept of pagination in Elasticsearch, specifically focusing on deep pagination. Imagine you have 100,000 documents stored in an index. How do you efficiently retrieve the information you need? This is an important question because attempting to fetch all documents at once can be inefficient and slow. Pagination comes into play here, allowing you to retrieve data in smaller chunks. This approach enhances the performance and efficiency of your system. Users will benefit from a quicker search experience. And if you are utilizing Elasticsearch in the cloud, pagination proves to be cost-effective. This image illustrates how pagination appears to users. Here you can change the size of the data that you want to get. For example, each request will get you just 25 documents. But if you want to get the subsequent documents, you can click on the next button to retrieve the next batch of data. This is just an example, but if you want to read more about this, please check this Medium article. In Elasticsearch, there are 2 primary methods for implementing pagination. From size, this method is commonly used for paginating smaller datasets, and the search after method, which is better suited for larger datasets. Let's start with the from size method. In this index, the from parameter indicates where Elasticsearch should begin fetching documents, while the size parameter specifies how many documents to return. If from is set to 0 and size is set to 8, we will retrieve the first 8 documents from the index. If we change from to 5, Elasticsearch will skip the first 5 documents and start retrieving from there. Note, this method is not usable if you have more than 10,000 documents in your index because it demands significant memory for deep pagination. Each time documents are skipped, performance slows down, making this approach unsuitable for larger indexes. Now let's explore the search after method. For this method, each document must include a sortable field, such as a document ID or a timestamp. You begin by setting the size parameter, and Elasticsearch returns the first 8 documents along with corresponding sort values. For subsequent requests, these sort values are used to skip documents, and at the end, you get the new source values. You keep doing these subsequent requests until you reach the last documents, then Elasticsearch will not return to your source values, and this is how you know how to stop making requests. Note, the search after method does not have the same 10,000 documents limit and does not require the from parameter. The results returned by Elasticsearch must be sorted by the sortable fields. The search after method relies on a pointer derived from the sort values of the last documents from the previous page. This is how it knows how to skip documents. Finally, this method eliminates the need to skip documents, making it efficient for large indexes. So we have seen the pros and cons for each method. Now I would like to benchmark both of them to determine which one performs better. And here is what I did. So I tried to retrieve 10,000 documents by using the following parameters. Size was set to 200 and I made 50 iterations. And here are the results. In the first graph, the from size method is represented in blue, while the search after method is in orange. The graph reveals that as we attempt to retrieve deeper documents, the response time significantly increases for the from side method, whereas the response time for the search after method remains relatively stable. In the second plot, we compare the distribution of response times. The histogram shows that the search after method consistently delivers faster response times, clustered around 2 and 5 milliseconds, while the from size method displays a broader range of response times, peaking at 16 milliseconds. This suggests that search after offers more predictable and superior performance for pagination. I also tried to compute some statistics from those graphs, and they confirm that the search after method is the preferred pagination method because, as you can see, the average time is very small. You can see that the variation is very small also, but here you can see that this is the minimum value and maximum value for the from size method. And you can see that the performance degrades. This is what I show in the second table. You can see that the performance is calculated like this. We take the last page time and we divide it by the first page time. Basically, we take this response time at the last iteration and we divide that by the first time. Technically, we should take the maximum value and divide it with the minimum value, but we have some variation. But as you can see, even when doing that, we get a 3 times degradation for the from size method, while for the search after method, we don't get that much degradation. So it's more stable. And here, the problem with the from size method is that we cannot go past 10,000 documents. So imagine with me if you have 100,000 documents and you try to retrieve all those, the performance degradation will be even worse. This is why Elasticsearch doesn't allow you to go past 10,000 documents while using the from size method. Now let's go to VS Code to see how to implement this and to see how to make the benchmark. This is how I generated these plots, and I will show you how to do that also. Open notebook number 18. If you want to read more about the search after method, click on this link. And if you want to get the notebooks, please, you will find a link in the video description that will take you to GitHub. There you can clone the repository to get all these materials. After that, connect to Elasticsearch, and here we are going to prepare the index. This is very important. I told you that to be able to use the search after method, you need to have either a timestamp or an ID or any other field that will help you sort the documents. So here I have them both. A timestamp is a date, and here these 3 values are going to contain the contents of each document. So we will have a value, a category, and a description. Finally, I had the ID. Here you can specify these things. So if you want to force the number of charts to be 1 and number of replicas to be 0, you can do that. If not, you can just remove this. It is not that important. So let's create the index. So here I am deleting it, and then I create it one more time. And here I make sure to pass the mapping. Now we will generate 100,000 documents. Basically, here we are generating fake data. As I told you, we will have 3 fields: category, value, and description. So we are taking these documents, but I have a method that will change the value automatically. You can see that the value will change. So we will take the, for example, 200, and we will add a random value to it, just to have random documents in the index. So here we are copying the documents, we are adding the ID and the timestamp. This is very important because we don't have these 2 values in the documents in this list. So let's generate those documents. You can see that it says generated 100,000 documents. That's great. If you want to increase the value, you can do that just by changing this number. Now let's index these documents. Remember, whenever you want to make a lot of API calls or a lot of operations that are going to be sequential, use the bulk API. This is what we are doing. So here you can see that the operation that we are going to perform is index, and we are going to put the document inside the index name. We had this value on top when we created the index, and after that we just specified the fields. Let's do this. You can see that it took roughly 3 seconds. If you don't do the bulk API and you just use a for loop and index each document separately, that will take a lot of time. And here you can see that when we print the errors, it says false, which means that all those operations were successful. Now let's refresh. Basically, refresh tells Elasticsearch that, hey, the index has changed, it has new documents. Because if you don't do this, count might return 0 to you. Now it returns that we have 100,000 documents. That's great. Now we can start with the pagination methods. Let's start with from size. To use this method, you basically specify 2 parameters, from and size. So here we are starting from the first document and retrieving just 10 documents. And here we want to sort the documents by the ID as well as the timestamp. But you can, if you want to use just the ID, you can do that. Okay? You can see now when we print the hits, which is basically the documents that we got back, you can see that they are indeed sorted by the ID. And you can see that we started from the first document, which has the ID number 0, and we arrived at the 10th document. If I come here and skip the first 10 documents, you can see that we start from the 11th document. So this is how you use the from size method. So this is what I did in the second cell. Basically, I changed the from to 10. Now let's see how to use the search after method. It's similar. So you can see that we don't use the from parameter, but we use the size parameter. And here again, you need to sort the values. Here, this is very important for the search after method. You have to have a field that will allow you to sort the documents. And as I told you in the slides, alongside the ID and the other fields, you get something called source values. You can see that here, the source values in our case is the timestamp and ID, and this is what we are getting back. We are getting the timestamp and the document ID. This is how we use the search after method. Now to get the next batch, you use the source values for the last document to be able to get the next one. This is what I am doing here. You can see that I am taking the hits list, I am retrieving the last document, and I am getting the source value. Let me just print this for you, just to see how this looks like. You can see that I will take this value, I will feed it to the search after method, and it will return to me the next batch of documents. Okay, so now we have a difference. We have size, we have source, but we have a new parameter, which is search after. And what do we give it? We give it the source values for the last document. Now, you can see that the last document has this ID, document 9, but now you can see that the first document is the next one, which is document 10. Okay, good. So now we have seen how to use the from size method as well as the search after method. Now let's do the benchmark. The benchmark is simple. We will try to retrieve all documents. So we will start from the first index, which is 0, or from the first ID, which is 0, and we will stop whenever we get the last document. And we will do this in iterations. you can see that here, the page size is 100. I mean, we will change this value later. And the maximum pages, which is the number of iterations, is 50. So we will multiply these values to get the total number of documents that you will get. Here, I have 1050. And if I try to run this, I need to run the previous cell, it gives me an error. Why? Because if you take 1000 and multiply it by 50, that will give you 50,000 documents, which is larger than 10,000 documents. And this is what I said to you in the slides. Elasticsearch will not allow you to go past 10,000 documents if you use the from size method. But if I change the value from 1000 to 200, this will work. If you take 200 and multiply it by 50, it will give you 10,000, which is the limit. We are good. Now let's see what we have inside this method. You can see that it is simple. We are basically using the from and size parameters to get the documents. And on each iteration, we are calculating the response time. And we are adding that to this timings list. And finally, we return that list to be able to make the plot. So this is what we have done. Now we have a list of response times. We will use this to be able to generate those plots. Now let's do the same thing for the search after the test. This one is going to be a little bit different. So you can see that we have the same parameters, which are page size and number of iterations. Again, we have the timings lists, but here we will add a new variable, which is search after, because here we don't have the from parameter. So we need to use the source values to be able to make subsequent requests. For the first iteration, we will not add the search after parameter to the body because we don't have these source values. You can see here that we are going to make the search operation, but without the search after. Now, we have made the first request. Now we can take the last document and take the source values from it and put that inside the search after variable. Now, in the second iteration, search after will not be equal to none. It will have a value. And now we can add that to the body dictionary. And we pass that to the search method. And now this is how we get batches of documents with the search after method, even though we don't have the from parameter. And at the end, we basically return the timings list. Okay, so let's do this. Now we will plot the two lists to be able to compare the two methods. You can see that the from size method becomes worse than the search after method when you want to retrieve deeper documents. But at the beginning, both of them are not that bad, so you can use both of them. But on general, the search after method is perfect for all cases. You can see that the response time does not vary a lot, and this is what we can deduce from the first plot. Now let's calculate some statistics. You can see that here we are calculating the average, maximum, and minimum times for each method. And after that, we can plot the histogram. You can see that here we have for B. Here, basically, these values will change because each time you run the system, it will give you different values. But generally, the search after method is the best. Let's compute the performance degradation. Here it says 0.9 and 0.52. We arrived at the end of this video. I hope that you found it interesting and informative. Please, before leaving this video, leave a like and subscribe to the channel. See you next time. Hello everyone, welcome to another video. Today, we are going to learn about the ingest pipelines in Elasticsearch. You will learn what a pipeline is and when to use it. A pipeline allows you to transform data before it is indexed. For example, if you have some documents and created an index, you can pass them through an ingest pipeline before indexing. As I told you, ingest pipelines can apply transformations like removing fields, converting text to lowercase. If you want to read more about the processes that Elasticsearch offers, click on this hyperlink. Pipelines can include multiple transformation steps. For example, here I am showing that the data will be transformed 3 times. For example, here you can lowercase the text. Here you can add a field. And finally, you can set a value. After passing all the transformations successfully, the documents will be indexed with no problems. But what happens if one of the steps fails? We will see this later. We use the Ingest API to create or update a pipeline. You can do this by using the put pipeline method. You give it the ID, so this is how you identify your pipeline, and a description. And inside the processor's attribute or argument, you pass all the steps that you want your pipeline to execute. For example, I have the set transformation. This is going to set this field with this value. And I also have the lowercase process, which will lowercase the text inside this field that I called field. So here, this is just an example, but you should change this value with what you have in your documents. We can also simulate a pipeline. This is very important because before applying your pipeline to actual data, you need to test it, and you use the simulate method to do that. Again, we provide the ID. The ID here is for the pipeline that we already created. So if I go back, I already created this pipeline. If I want to simulate it, I will take this ID and give it to the simulate method. And after that, I need to specify or to provide it with a documents. So you can either pass one document or a documents list. Here, for example, I have 2 documents. Here you can see that I am passing some values like index, ID, source, but these values doesn't need to be actual values. So you can put anything. The most important thing is source. The transformations are going to be applied just on the documents. And after that, in the response, you will get the transformed documents. And after that, if you see that the transformed documents are correct, then you can pass to execute the pipeline on real data. Here I have another implementation. So if you don't want to pass the ID, you can give the pipeline directly inside the simulate method. In this example, I have just one process that lowercase the text. So you can either choose this or this one. With the Ingest API, you can also delete a pipeline. This is very easy to do. You just call the delete pipeline method and you provide the ID. The same for get a pipeline. This will just return to you the pipeline. Again, you specify the ID to be able to do that. I mentioned before that what happens if one of the steps fails. This is something that can happen because pipelines may sometimes fail. If that happens, you have 2 options. You can either ignore or handle the failure. Here, for example, I have my ingest pipeline. I had executed the first step. That's great. But when I started to execute the second step, I got an error. So if I decide to ignore the failure, the pipeline will skip the step that failed. In this example, step 2 failed. So I'll just skip it and execute the third step. How to do this? It's very easy. Here, when creating the pipeline, you specify, for example, let's say that step 2 is going to rename a field. If you want to use ignore instead of handle, you add ignore failure inside the process or inside the step. So here ignore failure is set to true, which means that if this step fails, I will ignore it and just skip to the next one. Alternatively, with the onFailure parameter, we can specify custom error handling steps, such as logging the error, or even retrying to execute the process, or sending notifications. I mean, you can do a lot of things. This ensures that the pipeline never stops and executes the rest of the steps. So, for example, here, step 2 did not execute well. We did get an error. So what we will do before executing step 3, we will branch out and try to do anything that we have specified inside onFailure. And then when we finish this, we go back and execute step 3. To implement this, again, inside the processors, you go inside the step and here you add onFailure instead of ignore failure. And here between brackets, so this is a list. Inside this list, you specify the number of steps that you want to execute. For example, if you want just to log an error, inside this list, you will have a step that will log the error. If you don't want to execute anything, you just specify an empty list, and this will just catch the error, but it will not execute anything. and then it will move to step 3. Now let's move to VS Code to see how to implement this. Open notebook number 19. You can see that we are going to talk about ingest pipelines in this one. Click on this link to read the documentation. There are a lot of things that ingest pipelines offer you, and you will find that information there. Also, if you don't have the notebooks, please go to the video description. You'll find a link that will take you to GitHub, and feel free to download the repository to get the notebooks and the slides. First thing, we need to connect to Elasticsearch. Then I'll start by creating the pipeline. This is very easy. As I told you, you use the ingest API. It provides you with the put pipeline method. And here you need to give your pipeline a unique ID. So this pipeline, it will just lowercase the case. This is why I give it this ID, and a description. Inside processors, you specify the transformations. Here I have just one transformation, which will lowercase the text inside the field called text. If I run this, it gives me a knowledge true, which means that I was able to create the pipeline. Now, let me try to get the same pipeline. I use the get pipeline method to do that. And as you can see, I have my description and my processors. This looks good. If I want to delete the pipeline, I can just specify the ID and it returns to me true. As I told you, before applying the pipeline to real data, you need to simulate the behavior of the pipeline. But first, because I deleted the pipeline, I will recreate it. And here's how you use the simulate method. You provided the pipeline. So here you can either specify the ID of the pipeline that we created, or you can come here and type in pipeline and provide the pipeline here. After that, you need to provide the documents. Here again, index, ID does not matter. You can put anything here. The only important part is source, because here you will provide the documents. And again, simulate method will not index the documents. It will just show you the behavior of the pipeline. So now, if you remember correctly, lowercase, this pipeline, it will lowercase the text. And I need to have a field called text. So this is what I'm providing here. This is the field, and this is the text that I have inside the field. So here you can see that it is uppercased. If I run this, it should be lowercase. And as you can see, we have source, which is our document. Here is the field, and now the text is lowercase, which means that the pipeline was able to run successfully. When you use the simulate method and you don't get errors, this means that you are ready to use the pipeline in real data. But let's say that I have changed text to content and I rerun this. Now it gives me an error. Why? Because it says that field text is not present as part of path, which means that I told the lowercase pipeline to search for a field called text, but here I don't have that field. That's why the pipeline was not able to run successfully. And if you get this, this means that you are not ready to use the pipeline for real data. So this is how you use the simulate method. Now let me go back to text. You can see that now it is working correctly. Okay, so we simulated the pipeline. Now we can use it. But how you do that? Well, first let me read the data. Again, I am using the dummy data JSON file, and I am uppercasing the text. You can see that the text here is uppercased for all documents. Let me create the index because I will run the pipeline and then index the results. Again, we are using the bulk API, and here are the operations. We will index the documents, and the index expects the document as the next values. So I am specifying that. You can see that the bulk API, before we were just using the operations, but now we are going to use the pipeline. So now what's going to happen? The bulk API will take the document. It knows that it has a pipeline. It will feed the pipeline with that document. The pipeline will transform the document, and then we will take the results and store it in the index. You can see that the pipeline comes in between the data and the index. And if everything works correctly, and we have seen through the simulate method that everything went well, we should expect that this will not return any errors. And this is what we observed. You can see that error is set to false. And now let me print the documents to verify that the text was lowercase. Because remember, I have transformed the text when I was reading the JSON file to be uppercased. Now let me search for all documents inside my index and see how they look like. And as you can see, the text now is lowercase, which means that the pipeline did not encounter any issue. Now, sometimes the pipeline can fail. Let's say that you have your JSON file. All documents are good. You have the text field, but for one particular document, you don't have that text field. The pipeline will fail in this case. We can handle the failure. Let me show you the first case where we don't handle the failure. What happens? So here I am creating a new pipeline. I called it pipeline number 1. And here, this pipeline, it has multiple transformations, but does not handle failures. The first transformation is lowercase, and the second one is set. So set searches for a field called text, and it gives it this value. Let me run this. We were able to create the pipeline. Now I have a document that doesn't contain the text field. And remember, the first transformation expect to have that field. You can see that we get a bad request. Why? Because the lowercase process could not find the text field. So this is what happens if you don't handle the error. But now let's use the ignore failure and on failure parameters to handle the errors. Okay, so this is the second part, handling the failure. So here I call this pipeline 2. Here again we have multiple transformations, but this time we will handle or ignore the failures. Again, we have the same processes. We have lowercase and set. But for lowercase, I have specified on failure. And here I have a list. Inside this list, I can add other processes that will execute when lowercase fails. And here what I am doing, I am adding the text field. So set will add a new field if it does not exist, and it will give it this value. And here, if set fails, I'll just ignore the failure and continue the execution. So now we have handled the error for the lowercase process. Now we can move to the next step and create a new field with this value. Now let's run this and see how this would work. Again, I have the same document, but this time I don't have the text field. But this time I am using the new pipeline. You can see that this time the index operation did not encounter any problem. And if I run the search, you can see that I have a new document. So let's see what happens. Initially, we had just the title and created on fields. We have them here. So you can see that we have title and created on. But we have created 2 new fields. Why? Let's go back. First, we provided the document to the index method. The index method will take the document and feed it to the pipeline. The pipeline will take the document, it will try to load cases, but it will not find the text field. So on failure will be triggered. And what it will do, it will set the text field with failed to lowercase. Let's see, we have the text field, and it said failed to lowercase. Good. We have finished with the first process. We will continue. We have another process which will set a new field with this value added by pipeline. Let's verify if this is correct. And see that we have the new field, and here is the value added by pipeline. So this is how we use pipelines, and this is how we handle errors if they occur. We arrived at the end of this video. I hope that it was helpful and informative. Please, before leaving, leave a like on this video and subscribe to the channel. See you next time. Welcome everyone. Today, we are going to explore ingest processors, a feature that helps transform and enrich your data during the ingestion process. We will be covering the most common processors that you can use in your pipelines. In the previous video, we have seen that the process of ingestion has 3 main components. First, we begin with documents. These documents then flow through what we call an ingest pipeline, which consists of one or multiple sequential steps. Each step can apply various transformations, such as removing fields, lowercasing or uppercasing text, removing HTML tags, and more. Finally, the processed data arrives at your target index, ready for use. We can organize the ingest processors into 5 main categories. The first one is data enrichment. This category includes processors like append, inference, and attachment. Append adds one or more values to an array field, while inference uses machine learning to add predictions or classifications as new fields. For data filtering, you have drop and remove. Drop completely deletes the entire document from the pipeline if it meets certain conditions, while remove removes specific fields or values from within a document. The third category is array JSON handling. Here you will find processors like for each, JSON, and sort. We have pipeline handling. This category contains processors like fail and pipeline that manage the data processing flow. Fail generates an error and stops processing when a specified condition is met, while pipeline routes the document to another ingest pipeline for further processing. Finally, we have data transformation. This is our largest category, containing processors like convert, which changes the data type of a specified field, such as converting text to a number, rename, changes the name of a field in the document, set assigns a specific value to a field, HTML strip removes HTML tags from a field. Lowercase and uppercase are self-explanatory. We have trim. It removes leaving and trailing white space from a field's value. And finally, we have splits. This one divides the content of a field into an array using a specified delimiter, for example, like a comma. Now let's go to VS Code to see how to implement some of these processors. Open notebook number 20. You'll find the notebooks and the slides on my GitHub repository. The link can be found in the description. First, you need to connect to Elasticsearch. Here you can see that I have a section which I called common ingest processors because I will not talk about all of them. I will just take the most common ones like convert, rename, set, etc. But to be able to use these processors, we need a document or a set of documents. But this time I will just have one for demonstration purposes, like this one. Here we have price, old name, description, username, and each one of these fields will use a processor, or each one of these processors will perform transformations on specific fields. For example, the convert process will convert price from a string to a float. Okay, let's create the document. After that, we are going to create the pipeline. And inside the pipeline, we have all the processors, which are these 10 that I have listed here. Let's start with the first one. Here we have convert. It takes in the price field and converts it from anything to float. If the convert process does not find price, it will just ignore the error. It will not throw an error. Let's close this. After that, we have rename. In our document, we have a field called old name. We will rename it to be a new name. Set. It will add a new field called status with a value active. If status already exists in the document, it will just change the value to active. HTML strip, it will take the description field and it will remove any HTML tag and it will leave just a plain text. Lowercase and uppercase are easy to understand. Trim. This process will remove any white spaces that are in the beginning or at the end of the string. Split will take the string and split it into an array. And here you can see that we specified that the delimiter is a comma. We have remove. This one will remove this field, which I called temporary field. And finally, here, because we have used the split on the tags field, it will return an array. That's why we are using the append to add a new entry to this newly created array. Let me create the pipeline. You can see that here it says pipeline created successfully. Finally, we are going to use the pipeline that we created to apply it to the document before indexing it. Here I was able to create the document successfully. Now let's use the search method to get us the document. To be able to compare, I'll just copy the document and paste it here. Let me open this here and let's compare. So here are let me also take this Now let's go back to the pipeline just to verify if everything went well. Okay, so here, this is our original document, and this one is the new documents that we got back when we applied the pipeline to the original document. First, you can see that convert takes in the price field and converts it to a float. This is correct. You can see that at the beginning, price was a string, now it is a float. After that, we have rename. Here, we used to have the old name field, now it was renamed to new name. Before, we didn't have the status field, but now it was added, thanks to the set process. HTML strip, you can see that here we used to have p tags, but now we removed them. Here we lowercase the username field. You can see that here it was not in lowercase, but now it is. After that, we uppercased the category. So category was books, now it is uppercased. Trim, you can see that here we used to have some spaces at the beginning and at the end of the string, but now they are removed. If I look at the title field. After that, we have split. You can see that here we have some items that are separated with the comma. Here we used the split and we told Elasticsearch to split this string into an array, and it did that. So we have our initial items, tag 1, tag 2, and tag 3. But here we have a new tag. Why? Because we used the append process. So we told the append processor to look for field or to look for the tags field and add a new value to it. And this is what it did. Finally, we have remove. You can see that before we used to have the temporary field in the document, but now we cannot find it. So you can see that the pipeline was able to run successfully. These are just some common ingest processors that I wanted to talk about, but if you go to the documentation, you will find a lot more. We arrived at the end of this video. I hope that it was helpful and informative for all of you. Please, before leaving this video, leave a like and subscribe to the channel. See you next time. Hello everyone. Today, we are going to take a comprehensive look at filters. While I previously touched on filters when discussing search functionalities, that was just a brief overview. In this session, we will explore the filter context in much greater detail. When performing searches in Elasticsearch, you can utilize either query context or filter context. Let's start with the query context. Here you have the user's query. After that, the query context tries to answer this question: how well does this document match this query clause? After that, each document receives a score, with the highest scores indicating the most relevant documents. In contrast, the filter context focuses on the question: does this document match this query clause? Here, the result is binary. Either the document is relevant or it is not. You might wonder, why should we use the filter context instead of the query context? You use it because it performs binary matching. There is no need for score calculations. Filters execute faster than queries, and ultimately, it consumes less CPU resources. If you are dealing with structured data, filters are the way to go. Structured data includes numerical fields, dates, Boolean values, or keyword fields. Filters handle these elements exceptionally well. So if you have structured data, please use filters. Let's look at some examples of how to effectively use filters. In our first example, we are retrieving documents from the phone's index. We are going to use the Boolean query because we are going to use compound queries. We have seen this in a previous video. Please check it out. Inside the filter query, we have two conditions. We are going to retrieve documents where the color of the phone is black and it comes from Samsung. You'll notice that the filter allows for a list of conditions resembling an AND gate in logic. An AND gate is simple. You have two inputs. In our case, it's color and brand. Here is our gate. If both conditions are met, we will get yes. Otherwise, we will get no. Example number 2 follows a similar pattern. but this time we will use a date field to demonstrate how to handle this data type. Here we use the range filter and specify the date interval with greater than or equal to and less than or equal to parameters. And again, this works as an AND gate. So here you have status and publish date. Now let's introduce a new concept, post filters. Post filters are useful when you want to apply filters after aggregations have been computed. They don't impact aggregations, but they filter the search results. For instance, in a website with faceted navigation, post filters enable you to narrow down what users see without restricting their options. Here you can see we have the categories. For example, here you have experience level and job type. And in experience level, we have entry level, intermediate, expert. These are our filters. But the numbers you see between parentheses are aggregations. Let's examine a practical example. Suppose we are working with shirts. Initially, I'll filter for Gucci shirts. This will exclude other brands, except Gucci. Next, I'll compute some statistics using the aggregation parameter to determine the count of available colors. This is the first thing I will do. After that, I will filter the Gucci shirts by color, specifically red, and perform a filtering aggregation. When you have aggregation after filter, we call it filter aggregation. Here it will count how many models are both red and Gucci. Right now we have finished filtering the shirts and computing some statistics. This is the moment to apply a post filter to limit the results to only red Gucci shirts. So we have computed the aggregations, we have selected only Gucci shirts, but at the end, if you want to show just red Gucci shirts, we can do that with the help of post filter. Now let's go to VS Code to see how to implement this. Open notebook number 21. Please, if you don't have access to the notebooks, you will find a link in the description that will take you to my GitHub repository. Feel free to clone the repository to access the notebooks as well as the slides. First, connect to Elasticsearch. And here I have added a new JSON file, which I called clothes. Let's open it to see what it contains. Here is the clothes dataset. You can see that we have 3 fields, brand, color, and model. Here we are creating a new index, and we use the bulk API to insert how many documents here we have. I think 100. Yes, we have 100 documents. We will insert them all into this index. Here it says false, which means that we were able to insert all documents. Great, let's continue. And to just verify, we can call the count method to get all documents that are inside the index. Now let's start with simple filters. Here you can see that we are using, again, the Boolean queries, and here we have just one condition. We want to get all documents where brand is equal to Adidas. Let's just verify. So I'll search for Adidas. Here you can see that we got 23 results. Let's run this, and here again, we get 23 documents back. If you don't specify size, this will return to you just 10. Let me remove this because that's the default value. But make sure to override it to get all documents at once. We can add another condition. So instead of getting all Adidas shirts, or clothes, we can narrow down the search to get just yellow Adidas clothes. So let me select this, and instead of blue, I'll change it to yellow. I'm getting 6 documents, and again, Elasticsearch gives me the same result. So this is how you use simple filters. But if you want to compute aggregations or even use filter aggregations and post filters, you need to look at this example. So here, again, we are working with the same index. First, we are filtering to get just Gucci clothes. So in total, we will get 30 results. After that, we will start computing aggregations. So here, again, make sure that when you use, because here we have text, you need to use keywords. Because by default, Elasticsearch will take the string and analyze it. So it will have 2 versions. It will have one version that will work for full text search and the other one when you want to do, for example, matching. If you want to look for a specific value, then use keyword. So we are taking all those Gucci clothes and computing the colors. So here it will tell me how many red Gucci clothes we had, how many blue Gucci clothes we had, etc. After that, we are going to take just the red clothes. This is why we added another filter query. So here, instead of getting 30, we will filter that down to, let's see, to just 12 Gucci clothes. Now, inside the same object, we are going to compute another aggregations. We call this filtering aggregations because it comes after filtering. And here we are going to compute the count of model types. So we have 12 red Gucci clothes, but how many models do we have? This is what we are going to get after executing these aggregations. Finally, we can filter the clothes or the documents even further by using the post filter. Initially, we filtered the clothes by Gucci, so we will be getting 30 documents, but after that, we will select just the red Gucci clothes. So let me select this. And at the end, we should expect to get 12 documents. Let me run this. And as you can see, here we have 12 documents that we got back. But we can access the aggregations individually. The first one is the colors aggregations. Let's select this. And as I told you, first we selected just the Gucci clothes. But after that, we wanted to know how many red Gucci clothes we have, how many blue ones, how many red green ones, etc. And this is what we get with colors aggregation. You can see that we have 12 red Gucci clothes, we have 8 blue Gucci clothes, etc. After that, we filtered the clothes by color, red, and then we computed the count of models. So let's get that. And we call this, you can see that here it's color red. Okay, so it's color red. After that, it's models. And then we can access the buckets, which is basically the values. So color red aggregations will take the red Gucci clothes and then compute the number of models. I mean, for each one of the models that we had. So model 1, for instance, we have 3 of them. Model 14 and the other ones, we have just 1 of them. So this is how you use aggregations before using post filter. But at the end, because we used post filter, we selected just the red Gucci clothes. And this gives us 12 documents. And let's just verify. So I'll run this. And at the end, I will show you the length of hits. And this gives me 10. Why? Because I did not specify or I did not change the size of the query. After post filter, I'll just specify that size should be equal to, let's say, 20. Now let's compute the other values. And now we get 12 instead of 10. We arrived at the end of this video. I hope that it was helpful and informative. Please, before leaving this video, leave a like, subscribe to the channel, and see you next time. Hello everyone. Today, I will guide you on how to use the SQL Search API to search for documents in Elasticsearch. This approach will be particularly helpful for those who are more familiar with SQL than with Elasticsearch's default query DSL. In previous videos, we used the query DSL to perform document searches. Essentially, you have an index and a query, which you provide to the search method. Elasticsearch then uses query DSL to return the best matching documents. However, there is an alternative. You can perform the same searches using SQL, providing a more familiar method for SQL users. The SQL Search API offers several useful parameters, including the limiter. This parameter specifies the character used to separate values in the output. For example, in CSV format, you might use a comma, but you can choose a different delimiter if needed. We have format. This one determines the format of the query results. Options include JSON, CSV, text, and others. Cursor is used for paginating results efficiently. Fetch size sets the maximum number of rows to return in each response. We have filter. This one allows you to apply additional criteria to narrow down the search results. We will see how to use this later. We have request timeout. This one defines how long the system should wait for a response from the server before timing out. Finally, I want to talk about page timeout. This one is similar to request timeout, but applies specifically to the time given for fetching and returning each page of results. This is crucial for managing performance in paginated queries, and we have other parameters. You can click here to check them out in the documentation. Let's walk through a simple example. We use the SQL API and call the query method. In this case, I have specified that the output format should be text. The query will select all rows from the library index, sort them by page count, and limit the results to the first 5 documents. Here, library is the index, page count is the field we are sorting by, and 5 indicates the size of the result set. Elasticsearch supports various output formats such as CSV, JSON, CSV, TXT, etc. To change the response format, simply include the format argument in your query method. Next, let's cover pagination. We use the cursor parameter to paginate through results. But how do we get the cursor value? It is straightforward. You run your initial query, which returns results along with a cursor value. If this cursor is present, it means there are more results available. If there is no cursor, you have reached the end of the index. Now let's discuss filtering. It is simple. Just add your filter query. The SQL API will execute the SQL query and filter the returned documents based on your criteria. And if you want to control the number of documents returned by the filter query, make sure to use the fetch size parameter. Finally, you can use the SQL Translate API to convert a SQL query into a query DSL query. This is helpful if you ever need to switch back to using query DSL and don't want to learn the syntax as an example. Using SQL in Elasticsearch is great for those who prefer not to learn query DSL. However, be mindful of its limitations. For more information on these limitations, please visit the official Elasticsearch documentation. Now, let's go to VS Code to see how to work with SQL in Elasticsearch. Open notebook number 22. Once again, if you want to get access to the notebooks and the slides, you will find a link in the video description that will take you to GitHub. Once you go there, feel free to clone the repository. Now, the first thing we need to do is to connect to Elasticsearch and then index the data. Here, I'll be using the astronomy JSON file. We had used this before. And now let's verify. So we should have 10 documents. Great. Now let's move to the SQL Search API. First, let's start with a simple select query. So here, I am selecting just the title. Let me show you how the astronomy JSON file looks like. You can see that we have some documents, and each document has 3 fields: the ID, the title, and the content. And here with this SQL query, we are just taking the title field and we are selecting all rows from my index and ordering the results by the ID field, and we are getting just the first 5 documents. So if I run this, you can see that we are getting the solar system, black holes, galaxies, the Big Bang theory, and finally the exoplanets documents. Now let's change the response format. To do this, you just pass another argument, which is called format. So you see this is basically a JSON object, but if I decide to use text instead, you can see that it is different. Or if I use CSV, you see that now we have a delimiter, which is a comma. So we can play with this. And here again, I show you how to use text. This one is CSV, tab separated value. So yeah, you can play with those values. Now let's move to filters. Filters are easy. So here I am selecting all documents from astronomy.json. But after that, I will select the document that contains black holes in the title. Basically, I should get just one document, and this is what I am getting. You can see that black holes has the ID number 2, which is this one. Pagination. I told you to be able to use pagination, you need the cursor value. But to obtain the cursor value, you need to make an initial request. So let's do that. So here you can see that I am using fetch size 5. You can either, limit the query to 5 in the SQL query, or if you don't want to do that, you can come in here and pass in the fetch size parameter. Now, if I run this, you can see that I get, this is the cursor value. And after that, this is what I can do. So I can loop until the cursor does not exist, then I will stop. But if the cursor value exists in the response, this means that there are still documents that I can retrieve. So after making the initial request, I was able to make another request that gave me 5 more documents. And finally, I got the cursor value, which is here, right here. But when I tried to make the request again, I didn't get documents because I was able to retrieve all of them. So when I reach this point, I will just stop and break out of the while loop. Finally, we have the translate API. Let me remove the file. You can see that initially this is the SQL query, but what if I want to get the query DSL representation? That's easy. So you use the SQL API, and here it provides you with the translate method. Basically, you pass the SQL query and you get back the equivalent query, but in query domain specific language that Elasticsearch understands. And you can see this did a great job. For example, here we have limits, which is equivalent to size. Here we have order by, which is sort. You can see that here we are sorting by the ID. Here order is descending. Great. You get the point. If you want to translate the SQL queries to query domain specific language, you can do that with the translate API. We arrived at the end of this tutorial. I hope that it was helpful and informative. Please, before leaving this video, leave a like and subscribe to the channel. See you next time. Hello everyone. Today, I will be discussing the time series data stream in Elasticsearch. By the end of this video, you will understand what it is and when to leverage it. When we talk about time series, we mean data points ordered by time. This data is collected at consistent intervals. For instance, monitoring CPU usage over time. In this figure, you can see an example of tracking CPU usage across time intervals, which forms a time series dataset. Managing time series can be challenging due to its rapid growth, especially when working with high-frequency measurements. If we return back to our CPU example, taking measurements, for example, every 100 milliseconds, and storing them for months leads to a substantial amount of data points. Another challenge is storing such a large volume of data. Eventually, you will need to decide whether to archive or delete ordered data to manage storage effectively. Why use Elasticsearch for time series data? Elasticsearch efficiently handles large data volumes. It supports real-time ingestion and querying, and it enables in-depth data analysis. Check out these recommended posts for further reading on big data and analytics. Now let's examine the structure of time series data. On the x-axis, we have the timestamp, and on the y-axis, we have the data itself. Could be temperature, disk usage, CPU usage, etc. Each data point is stored as a document. You can see that each document includes a timestamp and relevant data fields. Now let's talk about index lifecycle management. ILM automates index rollover and data management. It offers many benefits like storage optimization, efficient management of index size, and automated data retention. An ILM policy has 4 phases. The hot phase, here we have active data. We frequently update the index. Then we pass to the warm phase. Here we have less frequently accessed data, the cold phase. In this case, we will archive data for long-term storage. And finally, we have the delete phase, where data older than a specified threshold is deleted. We will see some examples to illustrate these phases. This is what we are going to do in these upcoming slides. So now let's try to visualize the ILM phases. Suppose that we configure ILM with these rules. Here are the rollover criteria. So age is equal to 30 days, or if we hit the size equal to 50 gigabytes, we'll try to create a new index to store the data. If the age of an index reaches 90 days, we will delete it. Now let's say that we created the first index. It will implement the ILM policy. Here we have the time series data. We will start by indexing the data into this index. Now, when this index reaches 30 days, it becomes read-only, and a new index is created for incoming data. After another 30 days, this second index also becomes read-only, and a third index is generated. Finally, after an additional 30 days, the first index is deleted as it hits 90 days old, while the most recent index becomes read-only again, continuing the cycle. Here are two examples of querying time series data. The process is straightforward. Use the search method with the following query structure. To retrieve data between two specific days, use a range query and specify the two parameters, the greater than or equal and less than or equal values. To perform aggregations, use the aggregations parameter. And inside, specify if you want to calculate the average, the maximum value, minimum value, or whatever. So these are two examples that showcases how to query time series data. Now let's go to VS Code to see how to implement this. Make sure to open notebook number 23. You can see that this time we have two of them, because the first one we will simulate, or we will try to index the data in an infinite while loop, and in the other one we'll try to read the data and see how to plot it and query the index. Again, if you want to read more about time series data stream, click on this link. It will take you directly to official documentation. And if you want to get access to the slides, you will find a link in the video description that will take you to GitHub. First thing we need to do is to connect to Elasticsearch. And after that, we need to define a policy. So here I'll change the policy name to number 2 because I was testing this before. And here are the phases that I was talking about in the slides. So we have a hot phase and a delete phase. When we start creating the index, we are going to store the incoming data points. So if the age of the index reaches 5 minutes, we will do a rollover. Rollover means that we will put that index in read-only mode, and we'll create another index that will store the incoming data. And if the age of the index reaches 20 minutes, we will simply delete it. Here you use the ES client, you access the ILM module, and here you have the put lifecycle method. You need to give it a name and the policy dictionary. When you do this, you should get acknowledged true, which means that you were able to create the ILM policy. After that, immediately we need to create the index template. Again, you give it a name. Here you have the index patterns. I told you that when we start, we create the first index. And then when the index becomes old, we will create another one. You need to have a prefix. And then this asterisk will be replaced by the number of the index. We'll see this later. But you had to specify this in the index patterns parameter. After that, you need to enable data stream because we are using time series data stream. And here is the template. Let me start with the mappings because that we have seen this before. Basically, here we have 3 fields: the timestamp, the CPU usage, and CPU name. For CPU usage, you can see this is a float value. And here we have specified another parameter, which is time series metric equals gauge. This means that we will get variable values. And for CPU name, you need to have time series dimension equal true because we need to have at least one keyword per field in our index. If you don't do this, you will get an error while trying to create the index template. So this is the mapping. Now we need to change some settings for the index. First, the mode should be time series because we are working with time series data. And here we are going to implement the ILM policy that we created before. So let's try to create this. Okay, so this is giving me some errors because I think I already have this before. Okay, I changed the name and index patterns to CPU example template instead of CPU usage data because I was already testing this and I created an index template with CPU usage data. So we tried to match that pattern, and this is why I was getting that error. Now we can start reading data from the CPU and indexing it to the index. Here we are using the psutil package. It allows us to get the CPU percentage, and here you have the interval. So here, each 100 milliseconds, we will try to read the CPU percentage and index that to the first index. So here we have the timestamp. We are using the datetime package to get that. Here CPU usage, as I told you, we are going to use psutil. And finally, this is the CPU that I have on my PC, so I hard-coded this value. But you can see that each data point is a document. So here, I think I need to change, the index alias to CPU example templates. Now, let me run this. Okay, so this is giving me some errors. So I'll just change it to UTC now. So now it is working. We are getting the data from the CPU and we are indexing the documents each 100 milliseconds. To verify if this is correct, let's go to the Scikit notebook. Again, we need to connect to Elasticsearch. Here, let me get the index name and put it here. And as you can see, we have 213. If I keep running this, you can see that the count keeps increasing because the while loop is running forever. This is great. Now, let's try to get everything. So we are using the search method. And again, I need to change the index. And here I'll try to get everything. So by setting the size to a very high value. Now, let me show you how to plot the data. You can see that we are using the matplotlib library. Here we are getting the CPU usage and timestamp values. And basically, we are using matplotlib to plot the data. You can see that here is the timestamp axis and here is the CPU usage percentage. Now, if you want to compute aggregations, it's simple. Sorry, I need to change the index to this one. And this gives us the average CPU usage, which is 34% in this case. First, you specify the index, and inside the body, you use the aggregations method. And inside here, we computed the average in this case. But if you want to compute the maximum value, you can do that. And you just change the index to this one. And this is the maximum value. Let's see if that's correct. Yeah, so here, I think I need to rerun this cell because now we have more data points. And yeah, you can see that this is the maximum value, which is 81%. Now let's monitor the index lifecycle. This is very important because this will demonstrate how the policy phases works. So here, just to make sure that everything is good, you can see that we have the CPU usage velocity policy v2. This is what we created right now. And currently we have just one CPU. You can see that, we had just one index. So this is the prefix CPU example template, and Elasticsearch added some string just to identify this index. Okay, so here is the name. Here is the policy that we are using. It's CPU usage policy v2, etc. So here you have a lot of information. And here we have another one. Yeah, this is the one that I used before recording this video. So CPU usage policy. So I don't want to look at this. I just want to look at the first one because this is what we created. Great. So if you see something, this means everything went well because we already enabled data stream here by adding this. If you don't add this, you will not get an output here. Make sure that you get something here before running the upcoming cells, because that is very important. Now, again, here I need to change this to V2. And as you can see, this gives us the life cycle of the policy. So far, we only have just one index. Now, if I take this index and paste it here, you will see that we can monitor the life cycle of one index, of a specific index. You can see that here is the age. It's 4.27 minutes. it was time since index creation is 4.27. If I keep running this, you can see that the age value changes. And now, in theory, if this hits 5 minutes, we should do a rollover and create a new index. But by default, ILM checks every 10 minutes for indices that meet policy criteria. This means even if the index reaches 5 minutes, we will not create a new index. We should wait 10 minutes for the ILM policy to do the periodic checking. If the age of the index reaches 10 minutes, we should see that we will have the first index. It will be in read-only mode, and we will have another index that will store the incoming data. So I will wait for 5 minutes and then I will show you how this looks like. I really haven't checked if we can change this default value. Maybe we can, but because I didn't find it, so I'll just wait for 10 minutes and then see what we'll get. Okay, I am back. I've waited for almost 10 minutes and you can see that I rerun this cell and now we have another index that was created. Now let me go back to the first index and try to examine it closely. You can see that the age resets. Here the action is complete. Let's compare it to the second index. You can see that the second index is in rollover mode. The age is the same. Phase is hot. So yeah, you get the idea. Now, if we wait for 10 minutes, this index will go to read-only mode and we will create a third index that will store the incoming data. Now, if I go to the first index, you can see that, and if I go back to the first notebook, remember, the delete phase will execute once the age of the index is older than 20 minutes. Now, you can see that currently we have two indices. The first one will get deleted automatically when it reaches 20 minutes. So I'll wait again and see what we will get. Okay, so I have replaced the index name with this so that I can get the explanation for all indices. And now if I click on crawlable elements, you can see that we still have two indices, but now for the first one, the action switched to delete. So this one should be deleted very soon. This one is still on rollover. It's a little bit tricky because I don't know what is happening. I was waiting for a lot of time. So now the age of the index is close to 40 minutes. We still have not been able to delete it, even though we specified that the minimum age should be 20 minutes. The second one, again, the age is 39 minutes, but we are still on rollover, so we didn't create the third index. So yeah, even though we have specified the criteria for each phase, Elasticsearch still does not respond immediately. I'm really not sure why, but I'll wait for more minutes and then see what will happen. Okay, so as you can see now, things have changed. The first index was deleted, and now we have a third index that was created. Let's run this cell to get an explanation of what is happening. Again, click on scrollable elements, and let's see. So now the first index, as you can see, it no longer exists, so it was the ATIP, but now this one went from rollover to complete. This means that the next phase will be delete. Now the third one is still on rollover. So this is what I was talking about in the slides, precisely in this slide. So the first index was deleted and the second one is in read mode and we created a new one. And the process will keep repeating. The problem that I have is that this does not follow the criteria that we have specified. So sometimes this will work. You will see that the physics will change in 10 minutes, sometimes 20, 30. I really don't know what is happening under the hood. And I didn't do a lot of research into this. But I just wanted to show you that the phases are working. And now let me just go back to show you that we still have a lot of data points. So here you can see that the first index did have a lot of data. Because now it was deleted, we went from 20,000 to 3,000 points. This confirms that the index was deleted successfully. We arrived at the end of this video, and it was a little bit hard because ILM policies are not that easy to test, so they need a lot of time to make sure that they are working. But I hope that you enjoyed the video, you found it informative, and please, before leaving the video, leave a like and subscribe to the channel. See you next time. Hello everyone. Today, I will talk about analyzers. You will learn how they are used to analyze text before indexing documents to an index. How are they used when searching for documents and the component that make an analyzer? Say that we have some documents. we extract the text from them. An analyzer basically processes text during indexing and searching. The outputs of an analyzer are a set of terms which we call tokens with their corresponding documents. Analyzers make searching efficient and accurate. An analyzer is a combination of three components. Character filter, this one is not required, and you can specify more than one character filter if you wish. Tokenizer, this one is required, and you should specify just one tokenizer. And finally, the token filter. This one, it's like the character filters, it's not required, and you can specify more than one token filter. And by combining these three components, we form an analyzer. Elasticsearch provides built-in analyzers. They provide ready-made options for processing text in various ways, and some of them are designed for specific types of data. Here are some common analyzers. We have the standard analyzer. You can see that this one does not have a character filter, but it contains the standard tokenizer and the lowercase filter as well as the sub filter as token filters. We have the simple analyzer. Here you can see that we had the tokenizer, but we don't have any character filters nor token filters. Whitespace analyzer, it's the same, but it uses the whitespace tokenizer. Finally, we have the stop analyzer. This one lowercases the tokens and removes stop words. And you have more. You can check the documentation to see a full list of built-in analyzers. As I told you in the beginning, analyzers are used when indexing and searching for documents. Let's start with the index time analysis. First, you start with your documents. You pass them to the tokenizer. The tokenizer outputs the individual tokens. These tokens are filtered by the token filters component and then stored in the inverted index. Now, when searching, we start with the query. The query is separated into individual tokens by the tokenizer and then filtered by the token filters. Finally, we search in the inverted index to retrieve the documents that match the query. If you want to read more about the three components of the analyzer, check out the documents. You can click on each one of these images to read more about the character filters, the tokenizer reference, and the token filters. Also, check this Medium post. I used it a lot as an inspiration when making this video. I think you will like it. Again, just click on the image and it will open the Medium article for you. Now let's go to VS Code to see how to implement this. Open notebook number 24. If you want to read more about the Analyze API, please click on this link. And if you want to get access to the notebooks as well as the slides, you will find a link in the video description that will take you to GitHub. When you go there, feel free to clone the repository and enjoy. The first thing we need to do is to connect to Elasticsearch. Then I will start with the character filters. Here, if you want to read more about them, please click on this link. Let's start with the first one, which is the HTML strip character filter. Here we use the Analyze API, and here we specify the character filter. So here we are not indexing anything, we are just experimenting with the character filter. So here is my initial text. Let's say that we extracted this from a document, and we want to pass this to the character filter. So this one is built into Elasticsearch, and it will remove any HTML tag, okay? So let's see how to remove this, or basically let's run this. And as you can see, now we have been able to clean this text. So we no longer have the B tag and no longer have the P tag as well as this. So now it is clean. I'm so happy. So this is how the character filter works, or the HTML strip character works. Okay, let's go to the mapping character filter. This one is straightforward. You just map a set of characters to another set of characters. So here we are mapping the Arabic numbers to their Arabic Latin representation or equivalent. So this is 0, 1, 2, etc. And if we find this in any string, we will basically map that to these numbers. So this is what I did here. So I saw Comet Sushinshan Atlas in 2024. So this one should be replaced by these digits. Let's see. We mapped these digits into the set that we had defined here. So this is how we use the mapping character filter. So I just took two built-in character filters, but if you want to read more, please click here. Now let's go to the tokenizer. Let's start with the standard tokenizer. Again, you use the analyze API, and here instead of using the character filter, you use tokenizer. And again, you have to specify the input text. So here, let's see how the tokenizer works. Basically, the tokenizer will take the sentence and split it into individual words or individual tokens. In the response, we get the tokens from here, and after that, we can just loop over them. Let me run this to see what we will get. You can see that the first token is the. Then we got number 2, quick, etc. And you can see that the case is not changed. For example, quick is uppercased, jumped is lowercase, etc. And here you can see the type of the token. So Elasticsearch tries to analyze the tokens for you. This is why we say that when we index documents, Elasticsearch tries to analyze the content of the documents. For example, the is a string, so it's alphanumerical. 2 is numerical, which is correct. And the rest is the same. Now let's see the difference between the standard tokenizer and the lowercase tokenizer. Basically, we have the same code. We just changed the tokenizer to lowercase. And if I run this, you can see that the tokens are lowercase. And this one, we'll try to remove any numerical digits. Basically, in this case, we removed number 2. So this is how it works under the hood. Let's see the white space. This one will try to split the sentence or basically the string by the white space character. In this case, brown foxes will be 1 token. Let's see. Yeah, so this is just 1 token because we told Elasticsearch to split this sentence by white space. Now let's move to the token filters. Token filters basically take the output from the tokenizer, as you can see. So first you need to use a tokenizer, and then you tell Elasticsearch how do you want to filter those tokens. So here I want to filter them by apostrophe. So this means that I will remove this. Okay, so if I run this, you can see that everything is correct. Everything is like before. But when we arrive at dogs, you can see that we keep dog, but anything that comes from after apostrophe will be removed. So this is how the token filter works. Let's see another example of a token filter. So here I am using the decimal digit token filter, and this one will work basically like the mapping character filter that we have used before. It will convert any numerical digit into the standard one, which is basically the Arabic Latin representation. So you can see that 2024 was converted to this. We have the reverse token filter. I mean, I don't know why you would use this, but I'm just showing you the built-in token filters that are inside Elasticsearch. You can see that we took, for example, I saw it was reversed to was, comments, it was reversed to this, etc. Finally, we arrived at the built-in analyzers. As I told you in the slides, analyzers basically combine the 3 components: character filters, tokenizers, and token filters. If we use the standard tokenizer or analyzer, so you see here we are using analyzer instead of filters or tokens or tokenizer, etc. because analyzer basically groups all those 3 components. So we use the standard analyzer, and let's see what it does. You can see that first it lower cases the tokens. So this is a character filter. So here basically we have a lowercase filter, and we split the tokens by using the standard tokenizer. We have the stop analyzer. This one, it will lowercase the tokens and it will remove any stop words. Let's run this. Let's see. So here I saw comet Sushita at last in. So it removed in and it removed 2024. So we can experiment with these to see which one will suit your use case. And here we have the keyword. The keyword analyzer is a little bit different than the other ones. So basically it will take the whole sentence and return it as a token. You can see that here I'm trying to loop over the tokens, but I'm basically getting the same input back. So this is how the keyword tokenizer works, or analyzer works. Basically, if you have, let's say, product IDs and you want those to be considered as a token, you can use the keyword analyzer to basically take that whole string as a token and not split it into multiple tokens. Finally, I told you that the analysis is done both in the index time and search time. Let's explore the difference between them. Here I will be creating an index called index time example. First, we set up the mapping where we define a field called content of type text. This field is configured to use a custom analyzer which we specify in the settings dictionary. Within settings, we define an analysis phase to customize how the text is handled. To begin, we add a character filter named ampersand replacement, which basically maps the ampersand symbol to the AND string. Next, we create a custom analyzer that I named custom index analyzer to make it simple. Here we are setting the type to custom to tell Elasticsearch that we are creating a custom analyzer. This analyzer, so here are the three components. The first one is character filter. We are using our custom character filter as well as the built-in HTML strip character filter. We are using the standard tokenizer and the lowercase filter token or token filter. Okay, so we take this and then we create the index. Here I have a document and finally I will index that document to the index. Okay, let's do this. Great, so here it says successful, which means that we were able to index the document successfully. Now what happens if I try to search for that document? So here we are going to use the search method and we are going to match everything because we have just one document. And here you can see that the text did not change. We still have the ampersand symbol. This does not mean that our custom analyzer did not work. This is expected because Elasticsearch stores the transformed tokens in an inverted index for searching purposes, while keeping the original document intact in the source field as we get. Because if you want to retrieve back the document, you want to retrieve the original document, not the one that was transformed because of the analyzer. I hope that this makes sense. And just to let you know that this is working, we are going to use the analyze method. We are going to provide it with the same document. And here you can see that by using the index name, we are going to use the custom analyzer because here we did not specify it. Now, look what's happened. You can see that here we have visit my website. Here we have the website link. And you can see that the ampersand symbol was converted to the AND string, which means that the analyzer is working. Unlike the index time analysis, search time analysis only transforms text when a query is performed. In this example, we will perform a search on the content field using the match query, which is ideal for full text searches. Here you can see that we are using an analyzer called standard. Basically, when you are in the search time phase, you can use any analyzer that you want. It does not need to be the same one that you used in the index phase, but be careful. When you change the analyzer, you might get different results. Here, for example, I know that this link exists or that this token exists. So if I search, it gives me the document. Great, because you can see that this is a token that we got back and we can use that to find the document. But what happens if I use, so this is the match query, which is used for full text search. But remember, when you use term, the token has to exist. If you provide a token that does not exist, you will get nothing. We saw that this one exists, but if I try to change the case of the text, you can see that this time we get nothing because term is used for exact matches. But if you use match, then Elasticsearch will see that this one is very similar to this one. The only difference is that this one is lowercase, but the other one is uppercase. So basically they are similar. But when you use term, this does not apply. Use this if you want to get exact matches. I hope that this makes sense. We arrived at the end of this video. I hope that it was helpful. Please, before leaving this video, leave a like and subscribe to the channel. See you next time. Hello everyone. Today's video is all about synonyms in Elasticsearch. This is part 25 of our series, where we will be exploring how to work with synonyms using custom analyzers. Synonyms help make searches more precise and accurate. They are effective in matching various ways people refer to the same concept. Synonyms use a syntax called Solr format, which we will dive into shortly. The Solr format offers a flexible way to define synonyms using two main types. The first one is equivalent synonyms. Here, you use a comma to list terms that mean the same thing. For example, if you have car, automobile, race car, or voiture in French, all these terms mean the same thing, which means that they are equivalent. If you are working with something like this, use the first type. The second one is called explicit synonyms. This one maps specific words to one term. For example, if you have personal computer, you can map that to PC. Or if you have iPod or iPod like this, you can map that to iPod without spaces or without dashes. So whenever a user specifies one of these terms, it will automatically look for this one. It's different than the equivalent synonyms. If you have car, it's the same as automobile. If you are using voiture, you could still find documents that contain car, even though in the query you specify voiture in this example. In the previous video, we covered analyzers. Synonyms can be used within analyzers and applied at both index and search time. Here, synonyms act as a custom token filter. This is how an analyzer looks like. And here I am defining a custom one. Basically, it contains three components: the character filter, the tokenizer, and the token filter. And to use the synonym, you specify it in the token filter. Now let's go to VS Code to see how to implement this. Open notebook number 25. If you want to learn more about synonyms, please click on this link. First, we need to connect to Elasticsearch. Here, I will start by showing you how to set up synonyms. First, as always, I like to start with the mapping. Here we will have one field, which is description. The type is set to text. And here we are using a custom analyzer. In the analysis phase, we are defining a custom filter, which I called synonym filter. Remember, we have three components: character filter, tokenizer, and filter. Now, this one, the type is set to synonym, and here are the synonyms that I have. So if you are using a synonym filter, you have to specify the synonyms set. Here I have, for example, you can see that here I am using comma separated terms, which means I am using the first one. So these are equivalent terms. So here I am using one explicit synonyms. So all these planets, Jupiter, Mars, Earth, etc., all of them are planets. So I can do this mapping. Okay, so this is the filter. Now let's see how to use that filter inside the analyzer. My analyzer is called Synonym Analyzer. I am using a standard tokenizer. I am not using a character filter, but for the filter, I am using the lowercase, which is built into Elasticsearch. And alongside that, I am adding my own custom filter, which is the synonym filter. Here, this is the index name. I delete it if it exists and create it. Let's run this. And here it says acknowledge true. Everything went well. Great. Let's continue. Now here I have some documents. I created a new JSON file. This is how it looks like. You can see that we have the description field and we have some documents just to test let me put this here, the synonym sets that we have defined above. Let's index everything with the bulk API. Here it returns errors false, which means that everything went good. Now let's start searching with synonyms. Okay, so we have used the synonym filter in the index phase. Now we can use it in the search phase. So here's my query. I am using a match query, and here I am using vehicle. If I go up, you can see that vehicle is equivalent to automobile and to car. And if I look at the documents, let me make this small. you can see that I don't have automobile in any of these. Sorry, I don't have vehicle, I think. Yeah. If I try to search for vehicle, you can see that I get nothing. But because we have defined that vehicle is equivalent to automobile and car, we should be able to get this document that contains the word car. Let's run this. And as you can see, I got back that document that contains the equivalent term. Now let's use another one. Here I have planet. And again, let me go back just to see what I have. Or I'll just copy this so that I don't go up and down. And let's put it here. Now I will use this query, and here I am providing planet. And remember, here we have, so every single word here, Mars, Earth, etc., are mapping to planet. And here I have a document that contains Mars. And here remember that we are using a lowercase filter. So this, during index time, it will be converted to lowercase Mars. And because we have already defined Mars in this synonym set, it will directly point to this document. So even though I am specified planet, I should be able, if I did have another document that contained, let's say, Earth, I should have got that back. Actually, let's just do this just to verify if this is working. So here I'll say I want to go to Venus. I'll say this. I'll rerun everything. And as you can see, I was able to get both documents, Mars and Venus. Because why? Because Mars and Venus, both of them are mapped to planets. Let me delete this cell because I don't need it. And now here, what I'm saying, expanded synonyms for search time only. When we created the index, we were using the synonym filter in both index and search time. But what if you want to use it only in the search time phase? You can do that. Let me show you how to do it. So here we still have the same mapping. You can see that here we have the description field. We had the type equal text. And here I have two analyzers, one for the index phase and the other one for the search phase. Okay, we have the same filter. I just changed the synonyms set. Let me collapse this. And here are my analyzers. Inside analyzers, I have index analyzer and search analyzer. You can see that in the index analyzer objects, I am using the standard tokenizer as well as the lowercase filter. But I am not using the synonym filter. I am only using it in the search analyzer. So now, if I create this index, the synonym filter will be used only in the search time or in the search phase. Let's create the index. And here I will insert the documents like we did before. But this time, we will be applying just the lowercase token filter during the index time. Great, now let's search. So here I'm using vehicle. And as you can see, I was able to get the first document because let's verify what we have here. You can see that inside filter, again, we are using the equivalent synonyms. So all these terms are equivalent. And when I give vehicle, I was able to get the first document. And here, the synonyms filter was used only when I try to search for a specific document. I hope that this makes sense. We arrived at the end of this video. I hope that it was helpful and informative. Please, before leaving this video, leave a like and subscribe to the channel. See you next time. Hello everyone. Elasticsearch is a powerful tool, but did you know it offers features that make it even more flexible and user-friendly? In this video, I will guide you through some key options like human-readable output, date math, response filtering, and more. Why should you learn these common options? Because they simplify managing Elasticsearch, especially when debugging. These options provide valuable features such as making output easier to read for humans, performing calculations on dates, and filtering responses efficiently. The best part, these options are compatible with all Elasticsearch REST APIs. Let's start with human readable output, a feature that formats statistics into an easily understandable format. This applies to metrics like disk space, time, memory, and more. Here is an example where we fetch the cluster statistics. By setting the human parameter to true, the output becomes much clearer. Before, max uptime was this value in milliseconds. You can see it's very hard to interpret, and heap max was in bytes, so this is a very big number. But after adding the human parameter and setting it to true, you can see that yes, we still have max uptime in milliseconds, but now it was converted to minutes. So it's easier to read that this cluster was up for 6.9 minutes. And the heap max size is 7.6 gigabytes instead of this very big number. Next, let's look at date math. This feature lets you perform calculations on dates like adding, subtracting, or rounding to the nearest day. Supported time units include Y for years, uppercase M for months, etc. To find the full list of time units, please click on this hyperlink. All expressions start with an anchor date. You can use now for the current date or specify a specific date. Just remember to append double pipes at the end of the string. Let's see some examples. The string now will return the current date. If we write now plus 1 hour, we will take the current date and add an hour. Here we are subtracting an hour, and here we subtract the hour. So we take 11:55, we subtract 1, it gives us 10:55, and here /d will give us the nearest day. So the nearest day is basically the same day, but we start from 0. And in this final example, we add 1 month to the specified date. And here you can see that we did not use now, but we used a string to specify the specific date. So it's 2024 11/16. And don't forget to add these double pipes. And again, after adding the month, we find the nearest day. Finally, let's talk about response filtering, which lets you customize what fields are included in the response. You can filter in 3 ways. Inclusive filtering, you specify the fields you want to keep. Exclusive filtering removes unnecessary fields, and you can combine these two together by using combined filtering. In this example, we are going to use the search method. Here's the index. Here we are going to match all documents, and by using the filter path parameter, we can filter the response. Let's see the situation before and after. And here we are printing the body. Before filtering, we had the shards dictionary, and each document contained the index and the score. Here you see that we specified that we only want to get the hits dictionary, and inside each document we want just to take the ID and the source, nothing else. After adding the filter path, you can see that this is what we are getting. We no longer have charts, we have the hits, great. And now for each document, we no longer have index and score. We only get the ID and source. You can use this if you get an object or a response that contains a lot of keys that you don't need. By using inclusive or exclusive filtering, you can select basically the fields that you want to get in the response. Now let's go to VS Code to see how to implement this. Open notebook number 26. If you want to read more about common options, please click on this link. And if you want to get the slides as well as the notebooks, you will find a link in the video description that will take you to GitHub. When you go there, feel free to clone the repository. First, let's connect to Elasticsearch. And now let's start with the human readable output feature. Here is how you do it. You add the human parameter and set it to true. And here I'm just looking at the statistics of the cluster, and I'm just taking JVM just to show you an example. So before, you can see that max uptime was in milliseconds, but now we have added a new key that gives us the same value but in minutes instead of milliseconds. This makes it very easy for us to read. Here, for example, heap used. You can see that here it was in bytes, but now we have it in megabytes. And the maximum heap size is in gigabytes instead of bytes again. Now let's go to date math. Here I'll use the dummy data JSON file because it contains the created on field, and we are going to use this in order to get documents and just to show you how to use math operations on the data type. Let's start with the search. Here you can see that I am not using now, so I am specifying a specific date. When doing that, I need to add the double pipe. Here I am adding 1 day to this, so it's going to become 2024-09-23. And here I am rounding to the nearest day. Basically, I will get this. So this expression will be replaced by this value. And here I'm using now/d. This will change depending on the day when you run this notebook. But the day I'm recording this, it will give me 2024-11-16. So we'll try to get documents that are in this range. Let's put this aside. And this should return to me how many documents? 4. Why is that? Because I forgot to delete the index. What it is? Yeah, so this index already exists. So I needed to do this in order to remove any documents that were present in the index. Now, if I index the documents, I should get just 2 documents. So here we added 1 day, but we can add 1 month if you want. And this will not return anything because here we will have 10/22 and all those documents were created in September. So this is why we get 0 documents. But you get the idea. I'm not showing you how to retrieve documents because you have seen this before. What I'm showing you here is how to perform math operation on dates. Now let's go to response filtering. As I told you, we have 3 types. Let's start with inclusive filtering. Here again, I will just get everything, every document that exists on the index. You can see that here we have charts, hits, basically here we have our documents. But what if I want to remove charts and get just the documents and get specific keys for each document? We can do that with inclusive filtering. Let me remove this because I don't need it. And this is how you do it. So here you specify the outside key, which is hits. Inside hits, you want to get ID and source. So this is what I did. This is the first field that I will get. And to add more fields, you just separate them with comma and you add the other one. So here I said that I will keep only the ID and source fields. Let's see if this is going to work. As you can see here, I have 3 documents in the index. So here is the first one, here is the second one, and the third one. And you can see that I am getting basically ID and source. I'm not getting anything else. But before doing this response filtering, you can see that we have index, score, charts. We have a lot of things that we don't need. Let's see exclusive filtering. Basically, exclusive filtering is the inverse of inclusive filtering. Here, you remove the fields. To do that, you just add this minus symbol. So here, this means that I will remove the hits dictionary and I will keep everything else. And as you can see, now we have shards, but we no longer see the hits dictionary. Finally, we can combine the 2. So here, I want to get just the hits dictionary and I want to get the ID for each document, but I don't want to see the score. So let's do this. Great. So here is what I'm getting. Finally, we have flat settings. I didn't show you this in the slides, but basically this one is very simple. Let's say that I want to get the settings for my index. Look what I can do. Here, you see how this is structured. You have basically a dictionary inside a dictionary. If you want to flatten that out, you can do that. Just specify flat settings is equal to true. And here, instead of having a dictionary inside a dictionary, you will use the dot notation. You can see that here inside index, we have creation date. But this was transformed to indexed dot creation date because creation date is inside the index object or the index dictionary. We arrived at the end of this video. I hope that it was helpful and informative. Please, before leaving this video, leave a like and subscribe to the channel. See you next time. Hello everyone. Elasticsearch is a powerful tool, but it can be resource intensive by default. If you are like me and using it for small projects, you will want to configure it to consume less memory. In this video, I will show you how to do that. By default, Elasticsearch allocates 50% of your system's available memory. For instance, my system has 16 gigabytes of RAM, so whenever I start the Elasticsearch container, it uses 8 gigabytes. This slows down my PC significantly and can even cause it to freeze because there is no memory left. For small projects and local setups, I think allocating just 1 to 2 gigabytes is usually sufficient. Here is how you can adjust Elasticsearch's heap size. The first step is to start the container. This is how you do it. You open your terminal and run the following command. I have it here so you can just copy paste it. After that, you specify your password, and when you see this message, it indicates that the container is running. Let me do this in front of you. You can see here is the command sudo docker start Elasticsearch. Now I need to type in my password, and when I see this message, it means that the container is running. The second step consists on accessing the container. So here we need to go inside the container. How do we do that? Basically, we run the following command. Again, let me do it in front of you just to see how this works. To search for commands that we have in your history, you can do this. For example, I can click on Ctrl R and then start typing and just hit enter. So this is the command sudo docker execute -u0. So here basically you will be considered as a root user, and here is the Elasticsearch container, and after that if I type in ls, all these files and folders are inside the container. Now let's move to the third step and the final step in this process. This one, here we need to create this file inside this folder, and here are the steps. So we need to run the following commands in order to basically, here is how you specify the memory that Elasticsearch will use. You need to add these two strings, xms to j and xmx to j. Here number 2, so this is, well, if I add this, Elasticsearch will use 2 gigabytes. If you want to change that to 1 gigabytes, change number 2 with 1. And this is how you do it. I want to go, so here I have the link. So if I do this cat, you can see that inside this file, I already inserted these two strings as I told you. So all you need to do is to run these commands. Let me search for them, echo these ones, and that will insert those strings in the heap.options file. And to verify that that was done correctly, just run the following command, which will output what is inside that file. And if you see these two strings, then you are good to go. Finally, you can exit out of the container and restart it. And from now on, Elasticsearch will only use 2 gigabytes instead of the 50% that was set by default. And as you can see, so this is just by looking at the memory. Let me do that again. So here, if I look at the memory, you can see that here I have 16 gigabytes. But if I go to processes, you can see that here Java basically is Elasticsearch. And here it is only using 2.6 gigabytes. Before it was using 8 gigabytes. And when I go to resources, I get that the memory is full. Sometimes that freezes my laptop. Honestly, when I tried to use Elasticsearch with just 2 gigabytes, it was fast as it was very enough for me. So this is what I am showing you here in this image. We arrived at the end of this video. You saw that this is, I think, something that is very important. I should have done this at the beginning of this series, but I didn't get any problems with Elasticsearch until recently when I was doing a lot of stuff, when I was recording and opening Chrome and other applications. That was hurting the performance of my laptop. So then I searched to change the memory allocated by Elasticsearch. And I think that this is going to be helpful for all of you. So please, before leaving this video, leave a like, subscribe to the channel. See you next time. Hello everyone, and welcome to this transitional video between phase 1 and phase 2 of the course. From now on, I will shift focus to the final project, where we will put into practice everything we have covered in the previous videos. No further videos on Elasticsearch concepts will be uploaded. As mentioned in the introduction, there won't be additional videos on Elasticsearch concepts or APIs. Instead, I will concentrate on the final project. It is designed to demonstrate how to apply what we have learned to a real-world project with actual data. The final project will involve building a website. We will be using Vue.js in the front end, Fast API in the back end, and the search functionality will be powered by Elasticsearch, and we will be using Python for that. The project's primary focus will be on creating a rich and effective search experience using Elasticsearch. The source code for the final project is available on GitHub. You can find the link in the description or click on the image to access it directly. Navigate to the final project folder. Inside, you will find the final code folder, which contains the completed project, and the Getting Started folder includes starter code to begin the project. To get started, open the Getting Started folder in your favorite code editor and follow the videos that are going to come. The final project will be divided into multiple parts, gradually enhancing the search functionality with everything we have learned. I hope you enjoy working on this project. See you in the next video. Hello everyone. In this video, we will begin building our website. In this initial phase of the final project, we will create an index and index over 3,000 documents. We will use the size and from parameters to control the number of results returned in queries. We will also perform multi-match queries to search across multiple fields, and the theme of our final project will be about astronomy. Here is a video that demonstrates what we are going to build. You can see that here we have an input text where we can type in the query, and here we'll get the documents. And these documents are related to what we type. We are going to build both the frontend and backend. As you can see, here we get, by default, we get just 10 documents, but in later videos, we will improve the search functionality to modify these values. I hope that you liked how the website looks like, and in the next slides, we'll see how to build this. Now, we will focus on the front end. As I told you in the beginning, we will be using Vue.js to create the front end, and it is done for you because we want to focus on using Elasticsearch in the backend. So you just need to install some dependencies. As I told you, you can find the front end or the final projects on my GitHub repository. Just click on the image, or you can find the link in the video description. I'll click on the image. So now we are in GitHub. This is my repository, and you will need to clone it to access the final project and the dataset we will be working with. Once you have cloned or downloaded the repository, go ahead and open it in your favorite code editor. I am using VS Code, and as you can see on the left, we have the notebooks folder, the data folder, and the final project folder. Open the final project folder. Here you have two subfolders, the final code. Here you'll find the final solution and the getting started, where you have just the front end and we will build the backend together. Open it, and here you have the front end. You can see that here we have a lot of files. Now, what you need to do is open your terminal and let's try to navigate to the front end folder. To do that, you just use the cd command. Here, I'll go inside the final project, getting started, and finally front end. Here we need to install the front end dependencies. Make sure that we have Node.js installed on your machine, then run npm install. This will create a new folder called Node Modules that contains all the dependencies. Once that's done, you can start the front-end server by running npm run serve. Click on this link and boom, your website is live. It looks great, but if you try searching for something, let me search for the Andromeda. Here I am pressing the enter key, but nothing happens, and even if I click on this icon, I get nothing. That's because we haven't set up the backend. Don't worry, that's what we are about to do. We have finished working on the front end. Now we will move to the backend. We will be using Python, FastAPI, and Elasticsearch. In this part, we will install the dependencies for Python, set up the backend server so that we can make requests from the front end, and configure Elasticsearch to be able to make queries. Now I'm back to VS Code. Here I will collapse all folders, and if you look, you'll find a requirements.txt file, and here are the requirements or the dependencies for Python. One more time, open the terminal. If you don't already have a Python environment, make sure to create one. I'm using Anaconda and I already have my environment set up. Activate your environment, then run this command. pip install -r requirements.txt. If I run it, nothing would happen because I already installed the dependencies, but for you, you will see that the packages are going to start to install. Once that's done, close the terminal and navigate to the backend folder. Open Final Projects, open Getting Started, and here is the backend folder. Let's do the same in the terminal. cd, Final Projects, Getting Started, Backend. Now if I close this file and open main.py, you can see that we have nothing. But here we will set up the backend server. But before that, I'll create a new file called indexdata.py. This one will be responsible for indexing the data. If I open data, the data folder, I have added another JSON file. This one is called apod because basically these are entries that I scraped from the NASA's apod website. This is how the website looks like. And as I told you, the theme of this final project is astronomy. So if I start clicking on the hyperlinks, you can see that we get some images about the universe. Let's look for another one, for example, this one. And what I did is that I wrote a script that will go through all those entries, take the title, take the description, and the date, the published date. And I created this data for you. And I'm also using this data on my own website. Basically, it's a remake of a pod website. It looks very old, as you can see, but I try to take the same data and make the website beautiful. So if you are someone who enjoys astronomy, please visit my website and give me some feedback if you want me to add something. And this is where I got the idea to work on the search experience, because currently on this website, I'm just using regular expressions to find documents or to find the related images to your query. But when I learned about Elasticsearch, I thought this is a good idea to implement this on the website. So index data is a script that will read apod.json and index all those documents inside it in Elasticsearch. We will start by defining a function called indexData that takes a list of documents as inputs. And here I am using type annotation to indicate the type of data that we are working with. Inside the method, we will create an Elasticsearch client using a helper method called getEsClient. This one we will put it in a utility file. So let's do that. utils.py, because we will be using it in multiple scripts. You should be familiar with this. We have been doing this a lot in the notebooks that we created. You can see that here we are creating an instance of the Elasticsearch class. And here, because we are using Docker, we are connecting to a local host. And if the connection is successful, I'm going to print the cluster info. But if for some reason you forgot to start the Docker container, you'll not be able to connect, and we are going to show this message. The problem with this method is that if you run the script and you forgot to start your server, this will run once and stop because it will not be able to connect to the server. So let's add retry mechanism to try and connect multiple times, and between each connection attempt, we will add a time.sleep so that we wait a little bit before trying to connect again. So this is how you do that. Here I have two parameters, max retries and sleep time. Here I have a while loop, so I will be executing this block 5 times at most. So let's pretend that we started the server and that takes 10 seconds. And then I immediately started this script. So the first attempt of connecting will not succeed because the container did not start. So here we'll try to wait for 5 seconds before making another attempt to connect to the server. And this will give us some time to make sure that we will connect, even if the container takes a little bit more time to start. And if after making all those attempts we don't succeed, we are going to raise a connection error. Now let's close this file and go back to index.data. indexdata.py, and here we need to import this method. Next, we need to create an index in Elasticsearch. We are going to create a method for that. Let's call it createIndex. And here we have some things that we need to import. First, let's import Elasticsearch. And here we have a constant. Because I want the name to be reusable, I might use it in multiple scripts. I will define it as a constant in a new file called config.py. And inside, I'll just take this, put it inside, and let's name it a pod. Now close config.py and import the constant. As you can see, the create index is very simple. It just deletes the index if it already exists and creates it another time. And here we get the response. Now let's call that method from within index data because it is the main function. And the logical next step is to read the data and index it in this newly created index. For that, I will create again another method that will do this. And here I need to import tqdm. So from tqdm, import tqdm. And here we are using the bulk API. You can see that we are reusing the things that we have seen in the previous episodes. So I think you should be familiar with all these terms. So here we are getting the list of documents, we are getting the ES client, and here basically we are making the operations and passing that to the bulk API. After executing this method, all those documents are going to be indexed. Let's not forget to call that method from within index data. Finally, if everything goes well, I will show this message. Here I'll just print how many documents were indexed, and here let's import preprint. And now we need a way to execute this script from the terminal. That's easy to do. Just add this block, and here I need to import JSON so that I can read the JSON file. Inside this block, we get the list of documents, and we pass that to the index data method. This JSON file contains, I think, over 3,000 documents. Yeah, it contains 3,255 documents, which is a lot. That's great. And all of them come from NASA's website. So now I think we are done with index data. Now we need to go back to main.js or main.py so that we create the server. But before I do that, I need to index the data. Again, open your terminal and start the container. Open the terminal, and here I'm on the final project, so that's not the right path. So let's go to final project, getting started, and backing. Now all I need to do is from iPhone index data. Here it is telling me that it couldn't find the file. That's because this relative import is not correct. So let's fix this. I need to go back 3 times before I find the data folder. Now I just want to show you the retry mechanism. So I'll just stop or restart the container. Now let's again run the same script. You can see that here it says could not connect to Elasticsearch, retrying, and after that it freezes for 5 seconds. It tries to retry again, and eventually it will succeed. Here we get another error inside create index. Yeah, so here I was passing the index name, but I already imported it, so I don't need to do that. I think, yeah, inside insert documents also, I need to remove this. I think we are fine. So let's save the file and retry again. Okay, so now everything went well. You can see that we printed the clusters info, and after that we indexed the data using the bulk API, and here we printed that we indexed 3,000 documents into this index. Now let's create the API using FastAPI. Add this code to main.py. Here we are creating a FastAPI app, and we are adding middleware to allow the front end to make requests to the backend, because by default the front end runs on a server and the backend runs on another server. And by default, if you are trying to make requests from a server to another server, you'll get blocked by coarse middleware. So this is why we are adding allow origins, and here by adding this asterisk, we mean that any server can talk to any server. So we will not block requests just by adding middleware. After that, we need to define the endpoint. An endpoint is the URL that the front end will use to send the request. So if I want to search, let's say that I am typing in the input text and I want to take whatever I typed and send it to the backend. I will try to go to this URL and send the query to the backend. And the backend will receive it because here we are defining this get endpoint. And this endpoint is linked to this search method. So whenever the front end sends something, the search method will be called. And here we have some parameters like search query, skip, and limit. Skip basically is the offset. It's the from parameter in Elasticsearch, and limit basically is the size. Inside the search method, we will do a simple search query like what we used to do before. Again, we create the Elasticsearch clients. Here we are using the same method that we created before. We call the search method. We provide the apod index, and inside body, we are making a multi-match query. This type of queries allows us to search in multiple fields. Let's say that I typed Mars. By using multi-match query, I will search if that term exists in the title and or the explanation. As I told you, we are using pagination. So skip is basically from and limit is size. And we are also using filter path to filter the results to get just the document which is stored in source and the score related to that document. And finally, we return the hits dictionary. You can see that in one method, we have used a lot of concepts that we have covered in the previous videos, like pagination, multi-match queries, the search method, pagination, and filtering the results. Now make sure to save all the Python files that you have created, open the terminal, and start the backend server. To start the server, you just run this command, fastAPI dev main.py, and you should see something that looks like this. Don't forget that my Elasticsearch container is still running, so make sure to run it if it is not. And I also need to run the front end. So let's go to Final Project, Getting Started, Front End. And to run the front end server, you run this command, npm run serve. Now we can click on this link. Okay, we get the same result as before. Let me just close these tabs. But before you saw that we were not able to make requests because the backend was not set up. But now we have everything, so we can test this. Let's search for Mars. You can see that we are getting the images back, which is great. And you can see that here, sometimes Mars or the term will exist in the title. Sometimes you can find it in the explanation. And here you can click on the image if you want to see it in full size. Let's search for Jupiter, another planet. You can see that we are getting Jupiter images, which is great. I love this one. Look at Jupiter close to the moon with Jupiter moons. So here we have 4 Jupiter moons. That's awesome. Great. So this is actually working. And that's it for this video. In the next episode, we will improve the search experience with advanced Elasticsearch features. Until then, have a wonderful day. Hello everyone. In this video, we will take another step toward enhancing the search experience. Let me walk you through what we will accomplish. Here is a preview of how the website will look by the end of the video. Notice anything new? Let me explain. First, I added pagination controls, allowing us to adjust the page size and navigate between pages. Next, I introduced a year filter, enabling us to filter documents based on their publication year. Finally, we will use aggregations to calculate the number of documents per year. Open the project in your favorite editor and go to utils.py. Here, I want to make some small changes. I am no longer printing the cluster info, and I will change max retries to 1 and sleep time by default to 0. We have a lot of work to do in this episode. I prefer to start with calculating the number of documents for each year by using aggregations. For this, I will create a new route that will receive the search query as input and output the documents count per year. Inside the method, we will create a new instance of Elasticsearch. Here, max retries is set to 1 and sleep time is set to 0. And intentionally doing this to prevent pausing the program. After that, we will construct our query. And this time, I will use compound queries instead of just leaf queries. Because we will be using filters later, this is why I made this change. And I just wanted to use as many things as possible so that we apply the things that we had learned in the first phase. Inside the bool clause, I have a must condition. If this condition is met, I will get documents back. Otherwise, I will get an empty list. Now we can pass this query to the body of the search method. Let's say that we are searching for the Andromeda galaxy. The search method will try to find those documents. When we get them, we will apply the aggregations, or we will try to compute aggregations. I am giving this name to the aggregations, documents per year, and we are using a date histogram aggregations. This is built into Elasticsearch. Basically, the date histogram aggregations needs a field mapped to a date type. Then I'm telling Elasticsearch to group the documents by year, and by default, the group by operation will give me the count of documents per year. Finally, we want the return format to be just the year without the month and days, because we are grouping the data by year. At the end, we are using filter paths to return just the aggregations without the other items in the results. We are not done yet. We need to return the aggregations. So here I have a method that will do that. I am calling it extract documents per year, and basically tries to get the aggregations dictionary and convert that into a dictionary where we will have the year and the value is the count of documents. For instance, we could have 2024 and the value will be like 60 documents, 2023, 50 documents, etc. And now we can return this as a response to the frontend to display this in the drop-down component. So let me just collapse this because we don't have a lot of space. Here, everything is good, but I'll try to put everything inside a try and except block because sometimes we might get some exceptions. So it would be great if we can catch them. So let's just return HTML response. The content will be the exception that we catched, and the status code will be 500 to tell the frontend that we have an error. And this will help us investigate what happened. Now, how do we test this? Here I have a good extension that I really like. You can search for it in the extensions store. It's called Thunderbolts. It's this one. Basically, when you install it, you will get this icon. Click on it. Here you can make a new request. I already did that. Let me just collapse this so that we get a lot of room to play with. And here, this is what you can do. So here we are going to make a GET request. Why? Because if I go back to the main file, you can see that here, this route is basically a GET request. And here we have localhost. This is basically telling that we are using our laptop. Here API/v1 basically is this route. So now what we can do is that I can copy this, open the Thunder client window, click on new requests, and here I'll again go here, copy this prefix, again click on new requests, put it here, and now I'll copy the endpoints like this. Let me collapse this. Now we need the search query. You can see that here you have query parameters. So I can copy this, paste it here, and set that value to Andromeda. and it will add it automatically to the endpoint. If you want, you can save the requests that you are making. Click on Ctrl S, and by default, you'll find it here. If you want, you can put your queries inside a collection. So I can click on these 3 dots, save to collection, and here I already have one, which is called Elasticsearch Course Pilot Project. Here I'll name this Get Documents Per Year Count, and click on Submit. You can see that here it says saved successfully. Let's close the window, click on Collections, and here they are. Now we are ready to make the request. Click on Send, and here make sure that we have 2 things running. The backend, if you forgot how to do that, basically you need to go to the backend folder and run fastAPI dev main.py. And the second thing is Elasticsearch. You need to make sure that the container is running. And as you can see, this is the name that I gave to my aggregations. It's called documents per year. And you can see that this is the format that I was talking about before. You get 2015, here you have the number, etc. Let me search for something new, like Artemis. You can see that here we only have documents up to 2021, which means that this is working. Now we can continue working on the search endpoint. Let's collapse the get documents per year count method because we no longer need it. Now let's go to the top. Here we have the search endpoint. We will add a new query parameter, which is the year. This one should be an optional query parameter. So this is how you do it. Here we make sure that the year is a string value. And here you can see, as you can see, it could be either a string or none, which will tell fastAPI that this is an optional query parameter. Here we have a good structure, but we need to change it because by adding the year, we need to add filters. And we cannot do that with the leaf queries, so we need to change this to use compound queries so that we can mix 2 things, the must clause as well as the filters. So let's start doing this. The first thing that I will change again is this. So I'll change max retries to 1 and sleep time to 0. Here, I'll just copy the query from the get documents per year count method because we will use it. Let's paste that here. So this is the starting point. This is exactly what we did before. We are just searching for related documents by using the multi-match query. Here we are passing the query that we typed in the input text, and we are searching if this exists either in the title or the explanation fields. Now the new thing is that we can add filtering. So let's do it. Because the year parameter can be none, we need to make sure that it isn't. So if year is valid, this means that the user has selected a year. We are going to add a filter. So inside the bool clause, we can add a filter. And here, because we are working with a date field, we are going to use range. And here we are searching for documents that are greater than or less than equal these 2 values. Basically, because we are getting just the year value, we are going to return all documents that are in 2024 or all documents that are in 2023. Basically, the value that the user will select. Now, query can be changed because we already defined it above. From size, these 2 values will stay. And now we need to add another value to filter path because we added the pagination controls. So we need to get the total number of documents so that we can compute the maximum number of pages. This is what we are going to do now. Here I have 2 methods that I need to paste. Here they are. Basically, the first one will give me the total number of documents. I'm storing this in the total hits variable, and I use calculate max pages to give me the maximum number of pages that we can page through. Finally, we add the maximum pages to the dictionary that we return to the front end, but here I made a slight change. Instead of accessing the hits array directly, I am using the get method. Sometimes we might get nothing, and that was causing a lot of issues. So in that case, if we don't find hits, we are just going to return an empty array. Now let's do the same. Open Thunder Client, click on Search Method, and here we need to add a lot of things. You can see that here we have search query, skip, and limit. but we can add the year. The good thing about this is that if I click on search, we can see that it works because the year parameter is optional. So even if I don't provide it, it still works. And you can see that we get the maximum pages. Now let's add year. Or before I do that, let me go to the other route and let's search for the same term. We used Pluto, and here we can see that we had just one image that was uploaded in 2024. If I search for Pluto and provide 2024, I should get just one document. You can see that here inside this list, if I collapse this, you can see that I basically got just one document and the maximum pages is equal to 1. Let's change this to 2015. So 2015 should give me 2 max pages, or max pages should be equal to 2. Let's collapse this and voila, you can see that this is actually working. Awesome. But what happens if I change the limit to 20? This time we'll get just one page. Yeah, because 20 contains the whole 19 documents. So these are things that we will play with in the front end. There you have it. These are all the changes that we needed to make in order to allow us to filter by year, compute the number of documents per year, make the pagination controls work. Now we are ready to test this. Open the terminal, make sure to navigate to the front-end folder and run npm run serve. Click on this link and now you have the website. Let's start by searching. You can see that I immediately changed one thing. I removed the send query button, and now when you type, we will detect the characters that you are typing and we are immediately going to search. Because Elasticsearch is so quick and because we are getting just 10 documents, this hardly takes 20-30 milliseconds, so it's very quick. And here are the buttons that we are added, or the controls. Here we have the pagination controls. So here you can see that we have 20 pages. So this is the max pages value. And now we can click on next to go to the second page or to go to the last page. If you want to go to the first page, you can do that. And here, look, we have 20 pages. If I set that the items per page is 20, this will drop by 2. And it did. So now we have just 10 pages and the max value is 50. So now you can click, you can scroll to see the images. When you are done, click to go back and keep going. Okay, now let's see. So we are searching here. Basically, we are typing S and we are getting something. But let's click on the all years drop down. You can see that in 2015, we have 21 documents. In 2024, we have 16. So let's click just on 2024. And you can see because we are using 50, we have just one page. But if I go to 10 items per page, we are going to get 2 because we have 16 documents in 2024. But what if you want to remove this filter? Just click on this X icon. And now you are back and here you have all the documents. You can search like this. And sometimes if we don't find a document that matches the query, we will show this no results found text. And this is a problem with the tokenizer. Basically, this token does not exist in the index or in the inverse index, which means that we cannot map this to a document. So this causes a problem because basically we are using the default tokenizer. And this is a great thing. So in the next video, we'll be using a different tokenizer to solve this issue. And this will be wonderful. We'll be using the things that we have seen in the analyzer video. But if I complete the query to Andromeda, Andromeda is something that exists in the documents. So let's search. You can see that here we have a lot of documents with this term. This is why we get them. But for Androm or something like this, doesn't exist. I hope that you find the video very interesting. You can see that I'm not diving deeper in the front end because what interests me is the back end. But you can find the code if you want to look at it. Everything is inside the front end folder. So go there and try to understand how this is working. I hope that you found this video instructive and informative. We will continue working on this final project. In the next one, as I told you, we will talk about tokenizers. See you next time. Hello everyone. Let's continue enhancing the search experience. In this video, we will implement the search as you type feature to address a problem we are currently facing. For example, if I am searching for the Andromeda galaxy and I type just the first characters, the standard tokenizer we used during index creation won't return any results because this term is not a complete token in the inverted index. To resolve this, we will switch to using the n-gram tokenizer, which will allow us to retrieve documents even if the word isn't fully typed. Why use the n-gram tokenizer? Let's break it down with an example. We will compare the standard tokenizer and the n-gram tokenizer using the word Andromeda. During index time, the standard tokenizer treats Andromeda as a single token. However, the n-gram tokenizer splits the word into smaller chunks called grams. For this case, with n set to 9, it generates progressively smaller tokens starting from A and building up to the full word Andromeda. The tokens produced by the n-gram tokenizer mirror how you will type Andromeda while searching. First, you type A, then N, and so on until you type the complete word. Now let's go to VS Code to see how to implement this change. Open the project and navigate to config.py. We will modify the existing constants by renaming one and adding a new one. Index name default is apod, which means that we will use the standard tokenizer, but the second one will use the n-gram tokenizer. Next, move to index.data.py and import the new constants. Instead of just index name, now we imported index name default and index name n-gram. To toggle between the standard and n-gram tokenizer, we will introduce a new parameter in the index data method. I will call that parameter use n-gram tokenizer, and by default it is set to false, which means that we will be using the standard tokenizer. Now go down and here make sure that you set to use n-gram tokenizer to true because we want to see the difference that this tokenizer will make. Now inside index data, I will pass this parameter to both create and insert document methods. So just come here and paste that new parameter like this. Let me close this because we don't have a lot of room to play with. Next, let's modify the create index method. Now we need to provide this parameter when defining the method, and here we will not set the value because we are already passing the parameter to the method. Then remove any existing code inside, and based on the use n-gram tokenizer parameter, we will determine which tokenizer and index name to use. So if use n-gram tokenizer is true, we are going to use the n-gram tokenizer. Otherwise, we are going to stick with the standard tokenizer. And the same thing for the constants. If this is set to true, we will use the n-gram index instead of the default index. Then delete the index if it already exists. Now, when creating the index, we will define custom settings. If we are using the n-gram tokenizer, we will apply the n-gram tokenizer that we defined below. This tokenizer accepts some parameters like minimum gram. It is set to 1, which means that the smallest token will have a size of 1. In the example that we have seen in the slides, we used the Andromeda word, so the smallest gram will be the character A. Max gram is set to 30, which means that the largest token can have up to 30 characters. And finally, token characters. Basically, here we'll filter letters and digits. If you don't want to filter anything, just provide an empty list like this. And basically, based on the value of use n-gram tokenizer, we are going to pass either the standard tokenizer or the Ngram tokenizer. So we will be able to switch this value to compare between the standard tokenizer and the Ngram tokenizer. Now we finished working on the create index method, collapse it, and now let's move to the insert documents method. Let's add the use Ngram tokenizer parameter to the method's definition, and again, based on that value, we will compute the index name. And once we get the index name, we can just replace this old constant. We finished working on the insert documents method. Now I have one last thing that I wanted to change is this. So we no longer have this index name constant, so we need to replace it. And this is simple. Again, just use the use Ngram tokenizer to compute the index name and just give it to the prettyprint method. We are now ready to create a new index using the Ngram tokenizer. Open your terminal. Make sure to navigate to the backend folder. Make sure that use Ngram tokenizer is set to false to reindex the data using the standard tokenizer. And I made sure to update the apod.json file with more documents to play with. And then if you are inside the backend folder, just run python index data. And as you can see, it says that here are the number of documents that we indexed to the apod index. And here make sure that Elasticsearch is running, because if the container is not running, you will not be able to index the data. Now let's change this to true so that we use the Ngram tokenizer while indexing. And as you can see, it says apod Ngram, which means that it worked. Now, open main.py inside the getting started folder. We need to import the new constants. So the default one and the Ngram one. Now let's locate the search method, and here you can see that we were using the index name method. We were using it here and inside the get documents pre-count endpoint. If I expand this, you can see that here we have it. So to change them both, just double click on it and click on Ctrl D to select them both. Here I need to click on both of these so that I select just these two. So double click and click on Ctrl D. And now I can change them both at the same time. And by default, I will use the index name Ngram. Now save, and later we will use the default one just to see the difference between the two. Okay, so now we are done. Before I launch the front end server, I just want to use this extension that I showed you in the previous video. Go to your collections or create a new request. Here I will use the search endpoints, and here this is exactly the example that I showed you in the slides. Now if I click on send, now you can see that it says connection was refused by the server. Why? Because I forgot to run the backend. Now inside backend, just use fast API dev main.py. Now the server is running. Now we can accept requests. If I click on send, you can see that the status is 200 OK, great. And we get the documents. So here is, you can see that this says the Andromeda Galaxy, which is great. If I type Andro and send the request, I still get documents back, and I can keep adding characters until I type the whole word, Andromeda. Awesome, so this worked. Now let's go back to main.py. Again, select this one and the other one, note this, and instead of using index name Ngram, let's use the default one, and let's see if this one will work. So the server will reload automatically. Go to the search endpoint. If I leave the search query as Andromeda, it will work. There is no problem with that. But if I start removing characters, you can see that we get nothing, because during the index phase, the standard tokenizer splits the document by using the white space character, and Andromeda as a whole will be a token. So if you type Andromed or Andromi, it will not work, because we don't have this specific token in the inverted index. So you see now the difference between the two. Now let's go to the front end just to see this in action. Again, open the terminal, make sure that you go to the final project, getting started, and front end. You don't need to change anything because I made the changes for you. We just care about the backend. Now inside the front end folder, run npm run serve. The server is running, so make sure to click on this link. Awesome. So we had our beautiful website. Now let's start typing. Okay, so we get something, and okay, so it didn't work because we forgot to change the index name. So let's go back to the Ngram Ngram index. Let's make sure that we have it both. Yeah, so it is set in both endpoints. And now let's retry. Okay, so Andromeda. So we can see that it is working. So just by typing these 4 characters, we are able to find documents related to this specific token. And now I can just start typing and get instantaneous results. And this is exactly what I meant by search as you type functionality. And I think this is something great to add to our website. We arrived at the end of this video. I hope that it was helpful and informative. Before leaving this video, if you liked it, please leave a like, subscribe to the channel, and leave a comment. And don't forget, I will still continue working on the search experience. I think in the next episode, we are going to work on the embeddings. So that will be interesting. So make sure to not miss that video. See you next time. Hello, everyone. In this section, we will focus on adding semantic search functionality. By the end of this video, you will be able to switch between semantic and regular search methods. As mentioned in the introduction, this video is about implementing semantic search. To achieve this, we will convert text into dense vectors using an embedding model from Hugging Face. If you are unfamiliar with embeddings, be sure to check out video number 16 where I covered them in detail. For document retrieval, we will use KNN search to calculate similarity scores and fetch the documents most relevant to the query. Now let's go to VS Code to see how to implement this. We will begin by defining a new index in config.py. Each document inserted into this index will include a new field called embedding. This field will contain the dense vector that we got after transforming the text by using the embedding model. That's all for config.py. Next, I will duplicate the index data.py script and rename it index data underscore embedding. This separation keeps the scripts clean and easier to maintain. Let's start changing this file that we duplicated. Start by importing the new index constant. Here we no longer need the Ngram and default indices, but instead we import the embedding index. We will also need the sentence transformers library and PyTorch to handle the embedding model. So let's import those. Now go down. Before calling the index data method, initialize the embedding model. We will be using all-mini-lm. This is a small model that will run quickly if you have a GPU, or even if you don't have a GPU, you will still be able to index documents very fast with just your CPU. So after instantiating the model, we set it to the appropriate device, and this will automatically detect if you have a GPU or not. Now replace use ngram tokenizer with the model, because we will not be using ngram tokenizer with this approach. Update the function definition of index data to accept the model. Here we need to remove use ngram tokenizer and replace it with the model. Then we can see that we have some errors because we no longer have this parameter, so let's just delete this and this. And here let me just use the embedding index. Now let's go to the create index method. Here we need to change a lot of things. So let's just remove this return statement. Here we are not going to use the tokenizer. So let's remove that. Index name will be the embedding index. And here we will delete the index if it exists. But if it doesn't, we will create the index. But this time we need to do the mapping manually, because if you are working with dense vectors, the mapping should be done manually because Elasticsearch cannot infer that data type. So this is what we are going to return. So we are creating the index. Here I'm going to use index name, and here is the mapping. You can see that I am only mapping the embedding field because the other ones can be inferred automatically by Elasticsearch. So there is no need to map them manually. As you can see, the embedding field is a dense vector. Now let's go to insert documents. Here I need to pass the model, and I need to replace use engram with model. And here I forgot to remove use engram from the create index method. So let's do it. Again, index name, I'll just put it directly here and remove this line. Now, when we append the documents, we need to make sure that we are adding the new field, which is the embedding field. So how do we do that? It's simple. You will just put a dictionary, and here we are going to extract all the initial fields that we have in our documents, and we are going to add on top of that the embedding. And this is how you get the embedding. You use the encode method, and here we are going to convert the explanation from text to a dense vector. Why? Because the explanation contains the description for each entry, so this is what we are going to convert. And we are done with insert documents. Now, save the file, open the terminal, and make sure that the Elasticsearch container is up and running. Also, make sure to navigate to the Getting Started folder, go inside backend, and here, let's just run the new script that we created, index data embedding. So it takes a little bit of time to download the model, and that, as you can see, so in my case, it is very fast because I am using a GPU, but even if you don't have a GPU, this process will not take a lot of time because the model is very small. Okay, so it is done, and here it says indexed 3,333 documents into this index, which means that we are good to go. Now, the last thing that we need to do before testing this is to go to main.py. Here we need to add a new route. But before I do that, I will import again the same things. Here I need to import the embedding constant. Let's import torch and the transformers, the sentence transformers library. Let's also initialize our model because we will be using it. And we are doing this outside because when we are going to run the backend server, this is going to initialize immediately. Now we need to create a new endpoint. Let's call it semantic search. It should have the same parameters as the regular search method. So let me just copy them. Let's collapse the method, and below I will add the new semantic search endpoint. So let's name it semantic search. Here I'll just put path, but I will add stuff later. Now let's go back to the regular search, and here I want to rename this to regular search because we are going to change this in the front end. Before forgetting, please rename this to regular search. Let's copy some code from the regular search method. First, initialize the Elasticsearch client and then convert the query to a dense vector with the embedding model. The query should also change. Instead of using the multi-match query, we will use the KNN search. The field should be embedding because this is the field that contains the dense vectors. The KNN search expects the query to be embedded, and since we have less than 10,000 documents, we can retrieve them all to use pagination properly. After that, we can add the year filter. This one remains the same. We will not change it. I just copied it from the regular search method. And the rest should be the same. We just need to make sure to change index name to the new constant. And here we have the query. It was modified. So now we are using KNN search instead of multi-match. Skip and limit are going to stay because we are going to use pagination even though we are using KNN search. And after that, we will get the total hits and max pages. Finally, we will return the documents with max pages to use for pagination. So that's all. Now we can test this. Save main.py, open the founded client extension. Here, go to collections and create a new one for semantic search. So this is similar to the regular search. You just need to change this from search or from regular search to semantic search. Now, if I send this, it will not work because I didn't start the server. So let's do it. Fast API dev main.py. So here it takes some time before starting the server because we are loading the embedding model, but now it is up and running. Let's send the query. Okay, so application startup complete. Now we can send the query. It is processing, and as you can see, we got some results. You can see that if I close this, I have a lot of pages. If I increase the size of each page, that number should decrease. And yeah, it went from 167 to 67. Great, so it is working. Semantic search is different than using regular search because you saw that in the previous videos, when we were using the standard tokenizer, we were getting some documents, but if we type a string or a token that doesn't exist in the inverted index, we will not get results. We solved this issue by using the Ingest tokenizer, which lets you implement the search as you type functionality, but all those techniques works with tokenizers. But here with the k-means search, we are using the embedding. Here you will not search if a token exists or not. You are just going to compute this score value and you are going to sort all your documents based on this value. So now if I close this, you can see that this is 0.84, but if I go to the second page, you will see that this number will decrease. It's still 84, but let's go to the 10th page. Okay, so now it drops to 83. You can see that the documents are sorted by this value, which means that even if you type anything, you will still get documents because here we are comparing vectors. So here, we saw that for the standard tokenizer, if I type this doesn't exist in the documents. But if I send, I will still get documents. But you can see that the score is very low. This is the difference between using semantic search and regular search. Now, we tested this using the Thunder client extension, but let's not forget to go to the front end and run this in order to test it. The front end server is now up and running. Control click to open the website, and here let's start. You will see that I have added a new select box. Here by default it is using regular search, but I will change it to use semantic search instead. And now I can start typing, and as you can see here I typed Andromeda, and based on the description the embedded model was able to give us the closest documents to the query. And here you can see that we can still paginate through the results. We arrived at the end of this video, and we are getting closer to finishing this final project. I think I have one more video to work on, which will show you how to use ingest pipelines and ingest processors to transform your data before indexing it. Here I will be adding another file, another JSON file, where we will have this data but in raw format. It will contain HTML tags, and we will try to remove them by using the HTML strip processors. We are going to see how to implement this in the upcoming video, and it might be the last one. Please, before leaving this video, leave a like, subscribe to the channel. See you next time. Welcome back everyone. In today's video, we will explore how to handle raw data preprocessing using pipelines. I have added the raw astronomy picture of the day dataset to our project repository. It's important to note that this data is unprocessed. It contains HTML tags. Like this example, you can see that in the title we have this A tag, and also in the explanation field we have more tags like the P tag or the B tag. This is how the APOD data was before, but In the previous videos, I used the clean version, but this time I wanted to keep this one just to show you how to use the pipeline. In this video, we will use pipelines to remove HTML tags. Let me walk you through our data cleaning pipeline. We start with the original and processed document. We apply an HTML stripping processor to remove unwanted HTML tags. The result is a clean document ready for indexing. The pipeline approach allows us to transform raw data into format that is more suitable for analysis and search. By using an HTML strip processor, we ensure that our data is free from HTML tags, making it more readable and easier to work with. Here is the source of the raw APOD data. I created a script to scrape the entries displayed on this website. If I click on the first entry, you can see that we have a lot of information. Here we have the title, the image credits, here is the explanation, and we also have the date. But you can see that here, for example, we have a hyperlink. Some words are bolded, and when I use my scraper to scrape this HTML page, those stylings are stored in the JSON file. Now let's go to VS Code to see how to work with this type of data. Open config.py and add another constant for the raw data. Let's call it apod raw. Duplicate the index data script and rename it index underscore data underscore raw. Now, instead of importing the ngram and default indices, we will import index raw. Down below, change the data path to the new one, which is basically data/apod raw.json. Here we are not using the ngram tokenizer, so let's remove it. Go to index data, remove this parameter. And now, since we are going to use pipelines, I will create a pipeline ID. Here is my pipeline ID. I'll call it apod pipeline. And here we need to create a method that will create the pipeline for us. Let's call that method create pipeline. It will take the Elasticsearch client as well as the pipeline ID. The pipeline is straightforward. It contains a description, which tells you what it does, and uses the HTML strip processor on both the title and explanation fields. Let's collapse the create pipeline method. Here, we need to remove the ngram tokenizer. Inside create index, we need to remove all of this. And here, let's replace index name with index name raw. Here, there is no need to provide all of this. So this is how the create index method should look like. It will just delete the index if it already exists, and then create it one more time. Collapse the create index method, and let's move to insert documents. Again, let's remove the ngram tokenizer, but this time we will pass the pipeline ID. Here we are going to change the method's definition to add the pipeline ID. This is a string. Let's remove this line and use index name raw. To use the pipeline, it's easy. Just go here in this bulk method. We have a parameter called pipeline. We will just give it the pipeline ID. And that's it. So now you can collapse the insert documents method because we finished working on it. Here, remove all of this and just use the constants, index name raw. Now make sure to save everything. Open the terminal. Make sure that the Elasticsearch container is up and running. If it is not, you can run sudo docker start Elasticsearch to start it. Make sure that you are inside final project getting started backend. And now we can run our new script, index underscore data underscore raw. And here we don't have a lot of documents. I think we have only 200. Let me just verify quickly. Yes, we have like 183 documents, which is not that much, but it will show us the benefit of using ingest pipelines. Let me run this script. You can see that here it says connected to Elasticsearch, and the number of documents is correct. So it means that we indexed the data. How do we know that this is correct? Well, the answer is easy. Let's go to main.py. Here we need to import index name row, and we are going to use just the regular search endpoint. There is no need to use the other one, index name row. I will scroll down until I find the get documents per year count and use the row index also. Now save the main script, open the terminal again, and make sure to run fastcpi dev main.py. Here it is taking a lot of time because we are loading the embedding model. We have seen this in the previous video. Okay, great. So the backend server is now running. So it says application startup complete, which means that we can test this. Now let's open our extension, Thunder Client, go to collections, and let's use the regular search endpoint. So what should we expect? If the ingest pipeline works correctly, we should get the documents without HTML tags. Let me search for Messier. If I click send, you can see that we are getting 0. Why? Because here I have year, so let me just remove it. Maybe we don't have documents that were published in that year. And yes, that was the case. You can see that here we are getting documents back. The first document, you can see that it doesn't contain any HTML tags. Let's compare this. I will open the apod row file. Here, let me search for this specific document by using the date field. And as you can see, we have, let me just wrap the text. Here is the comparison. You can see that, for example, for the title, we used to have the A tag and the text was, sorry, let me just search for the same document. Yeah, it's this one. You see that we used to have the A tag, but this is the text that we wanted Messier for. And the HTML strip was able to extract that specific string. The same goes for the explanation. You can see that here we used to have this B tag, and some A tags. Now, in this output, you can see that all those HTML tags are gone. So this validates that the ingest pipeline was able to do the job correctly, but let's just run the frontend server just to see this in action in our website. Go to the frontend folder and run npm run serve. Okay, so here is our website. Let's search for Messier. You can see that we don't have HTML tags in the title and in the description, which means that this works. We arrived at the end of this video. I hope that you enjoyed it. Please, before leaving this video, leave a like, subscribe to the channel. See you next time. Hi everyone, and welcome to the final video of this project series. In this video, I will walk you through the last updates I have made and showcase the finished website. By default, when searching, we use the regular search method. I have added an option to switch the tokenizer from the standard tokenizer to an n-gram tokenizer. However, if you switch to semantic search, the tokenizer dropdown will disappear since it doesn't affect semantic searches. If I go back to regular search and change the tokenizer, the options in the year select box updates dynamically. For example, we have 9 documents that were published in 2015. But if I change the tokenizer to n-gram, you can see that now we have 271. This just shows you that the two tokenizers behave differently. If you already selected a year and then switch the tokenizer, everything will reset and the new values will be recalculated automatically. With these updates, the website now has complete functionality and you can manually adjust everything as needed. Throughout this project, my focus was on the backend, but if you are curious about the front end, feel free to explore the front-end folder. I used Vue.js to build it, and it should be straightforward to follow. If you have made it to the end of this course, I want to say you are amazing. I would love to hear your feedback, and I hope you found the course both interesting and informative. Take care. We have reached the end of this course. I hope that you enjoyed the journey. In this course, you have learned a lot of cool things about Elasticsearch, mainly the most common things that you will need to use. But if you want to learn other things, because Elasticsearch is very big and it contains a lot of things, I will make sure to link to the official documentation in the video description. Also, if you want to support me, I have my own YouTube channel. Check it out. I share a lot of videos about programming. Thank you once again for watching the course. Take care. Bye-bye.